Hey guys, tonight we're going to Antarctica. Not the touristy edge of it with the penguins and cruise ships. No, we're going deeper. Much deeper. You're standing at the edge of the world, quite literally. The wind cuts sideways. The sky is bruised purple, and the ground beneath your boots is older than anything you've ever stood on. Beneath this icy crust, beneath the cold silence and swirling snow, lies a continent full of secrets. Not rumors, not sci-fi fantasy. Real things, measurable things, unexplainable things. The kind of things that keep scientists awake at night and leave conspiracy theorists grinning in their basements. You've probably heard stories of weird maps that show Antarctica without ice, or lakes sealed in total darkness for millions of years, of strange signals coming from under the ground, of fossils that shouldn't be there, maybe even of Nazis. Yes, we'll get to that. But what if I told you there's even more things you haven't heard, things that haven't been explained, things that might never be? This isn't just a history lesson, it's a quiet unraveling. You're not here to memorize names or dates, you're here to feel it. The cold creeping up through your boots, the silence that hums like a question, the sense that something beneath you is waiting. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Let me know your local time and where you're listening from tonight. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You take a slow breath. The wind fades. Your steps crunch on snow as you move forward. Just ahead, something shifts under the ice, and before the night is over, you'll walk across magnetic scars, ice caverns that glow blue in total darkness, and lakes that haven't touched the sky in 15 million years. You'll stand where maps go blank, where microbes never needed the sun, where penguins once stood taller than men. You probably won't survive this, you know, not because it's dangerous, but because it's too strange to come back from unchanged. The kind of strange that rewires how you think about the planet you live on. Somewhere down there, the Earth is still breathing, very slowly, very quietly, and you're about to hear it. You make your way east across the endless white. The light here doesn't behave the way it should. It bends in odd directions, reflecting off ice so ancient it predates recorded history. There's no sound except for the crunch of snow underfoot and the steady hush of the wind, but even that feels staged, like the set of a documentary before the action starts. You're standing now above Wilkes Land, a place that looks like every other part of Antarctica, flat, frozen, and featureless. But what's beneath your feet doesn't care about appearances. Down there, something massive is hiding. You can't see it, but sensitive satellites can feel it. They measure gravity the way a hand might feel for a pulse, and under this ice, the pulse is off. It's called the Wilkes Land anomaly, and it's not a small quirk. It spans over 300 kilometers across and dives several kilometers deep. Gravity shouldn't behave this way unless there's something big down there, something dense. Some scientists believe it could be the remains of a massive asteroid impact, maybe even larger than the one that wiped out the dinosaurs. The timing's eerie. The crater, if it is a crater, may date back 250 million years, right in line with the Permian-Triassic extinction, the worst die-off in Earth's history. Over 90% of marine life gone. More than 70% of life on land erased. But here's the twist, no one has ever drilled deep enough to find out what's actually there. It's like seeing a body-shaped depression under the covers and never pulling the blanket back. Most of what we know comes from satellite data, gravity maps, magnetic readings, and radar scans. These tools don't paint pictures, they paint whispers. A dip in gravity here, a wobble in the magnetic field there. A few brave expeditions have tried to narrow it down, but Antarctica is not a willing host. Its ice is thick, stubborn, and shifting. Getting down to whatever is buried in Wilkes Land would require millions of dollars, a fleet of machines, and a rare window of stable weather. And even then, there's no guarantee you'd find anything. Still, theories swirl. The conservative ones say it's just geology, maybe a tectonic structure, a long-dead rift zone, or a mountain range that got smothered by the ice over hundreds of millions of years. After all, Antarctica wasn't always cold. Once it was part of Gondwana, the lush supercontinent filled with forests and rivers. Could this just be a fingerprint from that older Earth? Others believe it's the site of a massive asteroid impact buried so deep and so long ago that erosion and shifting continents hid the evidence except for gravity. That's what makes this mystery so strange. You can't see it, you can't touch it, but you can feel it in the way the Earth bends slightly downward in its presence. Something that powerful doesn't just fade, it stays, waiting. And then there are the fringe ideas. Some whisper that it's artificial, that beneath the ice lies a buried complex, circular, symmetrical, and perfectly placed. They point to the ring-like patterns in the gravity data and say, that's not natural. Of course, mainstream science rolls its eyes. There's no proof of a structure, no drilling core with metal fragments, no footage of ancient stone walls or tunnels. But there is also no certainty. And in the vacuum of certainty, mystery thrives. The Wilkes Land anomaly doesn't make headlines despite its size. You'd think the possible discovery of a continent-spanning impact crater, or whatever it is, would be the stuff of global attention. But it's mostly ignored. Research funding is limited. Expeditions are scarce. The data is there, but no one seems in a hurry to follow up. And that silence speaks. Maybe it's just the difficulty of operating in such a brutal place. Maybe it's scientific caution waiting until the tools improve. Or maybe someone has already been there, already knows what lies below, and isn't sharing. But let's not get carried away just yet. Let's just sit with what we do know. This mass beneath Wilkes Land warps gravity. It warps magnetic fields. It aligns with extinction events. It resists conformation. And that alone makes it worth paying attention to. Imagine you're one of the first scientists studying the maps. You see a dip in the data, a shadow in a gravity field. It shouldn't be there. The continent is supposed to be stable. But there it is, this slow gravitational bruise, spreading quietly under thousands of meters of ice. Your instruments keep confirming it, over and over, and still no one digs. Now picture yourself standing here right now above it. Snow is falling, but not heavy, just enough to catch in your eyelashes. The air is dry, cold, and perfectly still. Somewhere beneath your boots, so deep you can't comprehend it, something is pressing upward, bending the earth just slightly like the back of a sleeping leviathan. No vibrations, no hum, just presence. And what do you do with a presence you can't name? Scientists still argue whether it's impact or mantle uplift. Some say it's a misreading that gravity anomalies can sometimes lie. Others insist it's the largest crater we've never confirmed. A few quietly wonder if it's something else entirely. Whatever it is, it's been there for millions of years, undisturbed, untouched, and if it's waited this long, it can wait longer still. You take another step forward. The snow crunches. Somewhere in the sky, a weather balloon floats past, listening for echoes from below. You wonder if the Earth is hiding this secret on purpose, or if we're just too impatient to understand it. And so, the Wilkes Land anomaly remains invisible, immeasurable by human senses, but impossible to ignore. You move on. You descend farther into the continent now, away from the imagined crater, and into the icy highlands of East Antarctica. The wind sharpens, the air thins, and the silence folds in tighter around you. What lies ahead isn't carved in stone, it's sealed in water. Not the kind you can drink or see or even touch without drilling 4 kilometers down. It's called Lake Vostok, not because it's Russian, though the Russians did build a lonely research station above it, but because it waits. Vostok means east in Russian, but down here, it might as well mean unknown. The lake is enormous, comparable in volume to Lake Ontario, and has been hidden under Antarctic ice for over 15 million years. No light has ever touched its surface, no wind has stirred it, no rain has fed it, and yet it remains liquid. Just let that settle in for a moment. You're walking across a frozen wasteland, and under your feet lies a lake the size of a small sea, warmed not by sunshine, but by pressure and heat rising from the Earth's core. In the pitch-black isolation of its waters, something stirs. Scientists first discovered the lake in the 1990s using radar imaging. It started as a mystery in the data flat lines where there shouldn't be echo patterns that defied ice. And once they confirmed it, they were struck by how isolated it truly was. No rivers flow into it, no cracks connect it to the surface. It's hermetically sealed by over 2 miles of glacial ice. You might think nothing could live there. No sun, no air, no nutrients from the surface. But when Russian scientists finally pierced the ice in 2012 with a special drill system designed to avoid contamination, what they brought up changed everything. Life. Not seaweed or shrimp, just microbes. Tiny, unassuming, ancient, but unmistakably alive. Their DNA didn't match anything in existing databases. Some sequences were similar enough to known bacteria, but others entirely new. A few were so strange that they didn't even fit neatly into existing branches of the tree of life. What you're looking at is not just isolation, it's evolution in a vacuum. These microbes have been adapting in their own genetic bubble for millions of years. No sunlight, no oxygen, no predators, no distractions. Just pressure, darkness, and time. Lots of time. And what they've become, well, we still don't know. Research is slow. Funding is scarce. Regulations are strict. You can't just go melting into an untouched biosphere with a diesel-powered drill and a bucket. Every sample must be sealed. Every intrusion sanitized. The scientists worry rightly so that we might destroy what we came to learn from. But still we press forward. Because if life can exist here, cut off, silent, starless, then what does that say about life beyond Earth? NASA and ESA pay close attention to Lake Vostok. It's an analog, a stand-in for alien oceans buried under ice on moons like Europa and Enceladus. Those moons have thick frozen crusts and oceans underneath warmed by tidal flexing and geothermal heat. And if Vostok's conditions are survivable, perhaps even thriving, then we've just narrowed the search for life in the universe dramatically. But this lake still holds more questions than answers. One of the most hotly debated topics, the origin of its life. Did these microbes survive the freezing process trapped in the lake when the ice first formed millions of years ago? Or did life evolve there independently, completely cut off from the rest of the biosphere? Historians still argue whether Lake Vostok was ever exposed to the surface at all. Some propose it's been sealed since the time of the dinosaurs. Others believe the ice sheet may have receded periodically during interglacial periods, perhaps allowing for brief windows of exchange with the surface. If life entered the lake during one of those rare moments, it might resemble what we know. But if it's been locked away since before mammals evolved, then we might be looking at a parallel thread of life, a sibling lineage, not a descendant. There's also the question of what else might be down there. Sediment layers line the lakebed just like any body of water. Those layers are thick, compressed, and ancient. Some scientists speculate they could contain not just microbial life, but fossilized ecosystems, traces of past inhabitants that once thrived before conditions changed. Others imagine hydrothermal vents at the bottom of the lake, like the ones in Earth's deepest oceans, where chemosynthetic life clings to volcanic heat. If those vents exist, and if life surrounds them, then we may have found a functioning, self-sustaining ecosystem beneath 4 kilometers of ice. Of course, that's a big if. What we have right now are glimpses, test tubes of water, a few blurry radar scans, hints and hypotheses. But the story they're beginning to tell, it's not just about microbes. It's about time, Because this lake isn't just old, it's quiet. And in its quiet, it has remembered things the rest of the world has forgotten. Atmospheric changes, shifts in the Earth's magnetic field, glacial pulses, mass extinctions. All of it layered into its sediment like the rings of a tree or the grooves of a vinyl record. It's a time capsule, a library sealed in darkness, and we've only just cracked the door. Fringe theories, of course, have their own ideas. Some say that the lake holds more than bacteria, that radar imaging has detected geometric anomalies, right angles, dome-like structures, even symmetrical features that raise eyebrows. These interpretations aren't widely accepted, but they persist. Because down here in the cold and silence, imagination thrives. Could something artificial lie beneath that ice? Something preserved from a time before the world froze over, a remnant of a civilization forgotten not by war or fire, but by snow. There's no evidence for that, just a few odd echoes in the data. But it's enough to keep the theory alive. You press your gloved hand to the ice now. Beneath you, the lake sits dark and unmoving. The microbes drift unaware of your presence. They've been here since before the continents took their current shape, before apes, before pyramids, before stories. They do not care what we believe. They are not trying to be discovered. They are just surviving. And for now, that is enough. You make your way out of the icy silence above Lake Vostok and into the desolate vastness of the McMurdo Dry Valleys, one of the most barren places on Earth. There's not much here, just rock glacier and wind. And yet, as you round the snout of the Taylor Glacier, something strange comes into view. It's red. From a distance, it looks like an injury, a vivid stain pouring down from the base of the glacier, dripping like blood across the frozen ground. In this monochrome world of white, gray, and pale blue, it's the last color you expect. This, of course, is blood falls. You stop and stare for a moment. Because even if you've seen the photos, nothing quite prepares you for it in person. Rust-colored water spills continuously from the glacier's edge, running out into the valley in slow motion. It doesn't freeze the way you'd expect. It doesn't stop. It just bleeds. The name is poetic and maybe a little overdramatic, but it's not inaccurate. The red color comes from iron-rich brine water that's been sealed beneath the glacier for more than 1 million years. It was trapped there during an ancient freeze under immense pressure in complete darkness, with no access to fresh oxygen. Over time, iron in the water began to oxidize. So when the brine eventually found a fissure in the glacier and oozed to the surface, it met the air and turned red, just like blood exposed to oxygen. The science in this case is elegant, but don't let that fool you into thinking the mystery is over. Because the real question isn't why is it red, it's why is it flowing at all. Temperatures here routinely drop below 40 degrees Celsius. The glacier is ancient and static, and yet something deep within it is warm enough to keep liquid water moving. That alone is bizarre. Even more so, the brine is 5 times saltier than seawater, which helps keep it from freezing, but it's not just salt, it's alive. That's right inside that iron-rich, oxygen-starved liquid is life. Microbes. Living, thriving, doing their microscopic thing in complete darkness and chemical toxicity. These tiny organisms don't use photosynthesis. They have no sun. Instead, they rely on chemosynthesis, breaking down sulfates and iron compounds to generate energy. Think about that for a second. You and I need oxygen and food and sunlight. These creatures, they live in an iron-saturated brine sealed in ice, metabolizing minerals like something out of a sci-fi movie. And they've been doing it for 1 million years, quietly, patiently. The microbes at Blood Falls aren't just fascinating because of where they live. They're fascinating because of what they represent. A form of life completely independent from the surface, unaffected by seasons, isolated from every other ecosystem on Earth. They didn't evolve with us. They didn't migrate. They didn't even know the planet had trees or birds or a moonlit sky. They are quite literally their own world. And if life can exist here, if it can survive and even thrive in a hypersaline oxygen-deprived sub-zero brine under kilometers of ice, then where else might it exist? NASA and other space agencies have taken note. Blood Falls is one of the most Earth-accessible models we have for environments like Europa, Jupiter's icy moon. There, under a thick crust of ice, lies a subsurface ocean. No sunlight, no land, no surface runoff. Just water salt pressure and geothermal heat. In other words, a perfect home for microbes like these. Astrobiologists see blood falls as proof of concept. If Earth can support this kind of life in this kind of place, the chances for alien life, at least microbial, go way up. But back on Earth, we're not done asking questions. The brine flowing from blood falls is part of a larger underground network of liquid channels. These channels remain largely unmapped. We know they're there, radar detects them. Magnetic anomalies hint at their shape. Temperature sensors pick up subtle flows. But we don't know how extensive they are. We don't know where they start or where they end. Some researchers believe the system may span hundreds of kilometers beneath the dry valleys, acting as a secret vascular system for the glacier. Others suspect that different brine reservoirs are connected by narrow subglacial rivers, some permanent, others seasonal. A few bold theories suggest there may be entire underground lakes feeding the flow cut off for eons and home to ecosystems we can't yet imagine. Scientists still argue whether these features formed recently or have existed for millions of years. Some suggest they result from slow melt patterns caused by geothermal heat below. Others propose chemical interactions between ice and underlying rock create pockets of sustained warmth. And then there are stranger ideas. One theory points to periodic pulses in the flow of blood falls. Some years it's more active, some years less. Some believe this variation is caused by shifting pressures in the underground channels. Others think it might be magnetic changes in the Earth's field subtly altering the flow. Still others point to anomalous readings near the glacier, strange spikes in magnetism, inexplicable fluctuations in temperature. Small, rare, but enough to make some researchers raise their eyebrows. And where there are eyebrows raised, you can count on fringe theories to follow. Some people believe the red water is a warning, symbolic like a wound in the earth itself. They speak of ancient civilizations buried beneath the ice, their remnants now bleeding through the crust. Others imagine buried machinery, leaking long-forgotten chemicals. Still more see the glacier's unique location, a rare ice-free zone, as a deliberate opening. A weak point. Of course, there's no proof for any of that. Just rust and salt and microbes. But even the science refuses to fully explain it away. Why here? Why this glacier? Why this system of brine and salt and strange life? Blood Falls is unique, not because it's the only place with subglacial brine, but because it's the only one we've seen bleeding. And there's something profoundly unsettling about that. Something primal. It's as if the Earth is trying to tell us a story, but can only do so through leaks and stains. You stand in front of the outflow now. The red water drips slowly onto white ice. It hisses slightly as it hits the cold air. The stain it leaves glows faintly in the twilight. You don't move, because sometimes the most haunting places aren't haunted by ghosts. They're haunted by the persistence of life. Life that should have died out. Life that refuses to stay buried. And in the case of Blood Falls, life that bleeds through a glacier to remind us that this planet is still full of surprises. You leave the bleeding glacier behind your thoughts, still tangled with salt-brined microbes and impossible ecosystems. But tonight's journey has only just begun. As you head toward the coast of Queen Maud Land, something even stranger surfaces, not from under the ice, but from the pages of an ancient map. You're holding a reproduction of the Piri Reis map in your gloved hands now. Its original form was drawn in 1513 by an Ottoman admiral and cartographer named Ahmed Muhiddin Piri, better known as Piri Reis. He was a skilled navigator, a respected scholar, and a man who claimed to have access to secret knowledge passed down through generations. The map itself is beautiful, rich, with flourishes, coastal outlines, and notes in Ottoman script. It shows the western coasts of Europe and North Africa. It sketches Brazil with surprising accuracy. But that's not the part that makes historians shift uncomfortably in their chairs. No, what unsettles people is what appears at the bottom of the map: Antarctica, or at least something very, very close. The southernmost landmass on the Piri Reis map, drawn with what looks like coastal mountain ranges and inlets, seems to depict the northern coast of Antarctica as if it were free of ice. And that's where things get complicated, because officially, Antarctica wasn't even discovered until 1820. And it certainly wasn't explored in any detail, let alone mapped, before the 19th century. And yet, here's a map from 1513, drawn by a man working from older sources, showing land that shouldn't have been known. Skeptics will tell you it's not Antarctica. It's a misinterpretation. Maybe it's Tierra del Fuego, or an artistic guess based on faulty rumors from sailors. After all, mapmaking in the 16th century was often a mix of fact, myth, and hearsay. But others aren't so sure. In the 1960s, a professor named Charles Hapgood proposed a radical theory. He suggested that the Piri Reis map and others like it were based on much older charts, ones drawn by a civilization that existed before the last ice age. He called it Earth crust displacement, a fringe idea that proposed Antarctica was once much farther north and temperate before a sudden shift pushed it south and buried it in ice. Most geologists reject Hapgood's theory. There's no strong evidence for such a recent dramatic shift in the Earth's crust. Plate tectonics doesn't work that way. Still, the theory struck a chord with many. Even Albert Einstein, yes, that Einstein wrote a foreword to Hapgood's book, noting that while the idea was unproven, it was worth considering. Because here's the thing, parts of the Piri Reis map do align disturbingly well with modern scans of Antarctica's subglacial coast. Using radar and seismic data, we now know the shape of the land beneath the ice. And the match, while not perfect, is close enough to make you squint. Especially when you realize that this kind of mapping charting the contours of a continent buried under kilometers of ice would have required either modern satellite technology or a coastline that was actually visible at the time. Which brings us to the chilling possibility: what if Antarctica was once ice-free, at least partially? Not during human history, perhaps, but far earlier, before the last glacial maximum, maybe 20,000 years ago. There are studies showing that parts of East Antarctica may have had exposed land more recently than we thought. Maybe not tropical forests and cities, but tundra moss birds. Could oral histories passed down through generations have preserved distant memories of such a time? Could ancient seafarers whose civilizations we've lost or overlooked have glimpsed those shores? Scientists still argue whether ancient humans ever reached Antarctica. The mainstream answer is no. The icy conditions and remoteness would have made it nearly impossible. But alternate theories persist. Some suggest Polynesian navigators may have come close. Others whisper about ancient lost cultures with maritime capabilities far beyond what we currently believe. And so the Piri Reis map sits at the intersection of fact and mystery. It doesn't prove anything, but it doesn't go away either. To make matters stranger, Piri Reis wasn't working alone. He claimed to have compiled his map using at least 20 earlier source charts, some Greek, some Arabic, and some of unknown origin. He even annotated the map with a note saying that one of the charts dated back to the time of Alexander the Great. Think about that for a second. A military admiral in the 1500s, drawing from ancient scrolls, some perhaps copied and recopied from even older, now lost civilizations. A game of historical telephone, stretching back thousands of years, each version slightly different, yet somehow retaining a glimpse of a coastline we no longer recognize. And that, in a way, is the most haunting part. Not that someone might have seen Antarctica before it froze, but that someone might have remembered it long enough to record it. That knowledge could persist through war empire and collapse, whispering across time in ink and parchment. Of course, the skeptics return here to remind us cartographers embellished. They guessed, they mirrored coastlines, they loved their sea monsters and dragons. And yes, parts of the Peary race map are wildly inaccurate, but not all of it. Some features are eerily precise. South America's shape, for instance, is surprisingly close to modern forms. Rivers are placed with a level of accuracy that would have required direct observation or highly advanced calculation. How did he get that right? You kneel down now, your hand brushing the edge of an old reproduction laid out on the snow. The ink is cracked. The parchment flaps gently in the cold air, and that southern continent, whatever it's meant to be, smiles back at you like a riddle. Because it may not be Antarctica, but it also might be, and if it is, then the implications are enormous. It would mean rewriting parts of our navigational history, reconsidering what kinds of ancient knowledge have been lost, and reopening the debate on whether early humans had access to more advanced geography, perhaps even from a source we've forgotten. You exhale slowly. Your breath fogs the air and drifts over the outline of the map. The red coastlines ripple under it, flickering like a memory. You wonder if ancient sailors really did reach Antarctica. What did they see? Ice or open water ruins, or untouched wilderness? Did they record what they found? Or did they hide it, leaving only fragments behind? And if the Peary race map is one such fragment, then how many more are waiting? You fold the ancient map and tuck it away, your fingers still tingling from the weight of unanswered questions. But before you've even moved on from the implications of long-lost cartography, a new enigma catches your attention. This time, not drawn in ink or buried in ice, but floating gently down from space. Micrometeorites, cosmic dust, alien particles. You're in a sterile white lab now, somewhere near the Antarctic coast. The wind howls beyond reinforced steel doors, but inside tweezers hover delicately over petri dishes. Under the microscope, what looks like nothing, tiny flecks of dull metal and silicate becomes everything. Every year, over 100 tons of extraterrestrial dust settle on Earth, and Antarctica, ironically, is one of the best places to find it. Its pristine ice acts like a blank canvas. There's no soil, no trees, no industrial clutter to confuse the evidence. When something unusual falls from the sky, you can actually see it. That's why scientists dig here, not just for clues to Earth's past, but for fragments of other worlds. And sometimes, just sometimes, what they find is genuinely puzzling. One such discovery was made near Dome Fuji Station in East Antarctica. Researchers combing through blue ice fields collected hundreds of particles that clearly didn't belong. Some were rich in nickel and iron hallmarks of meteoritic origin. Others contained minerals not typically found in terrestrial geology. A few bore the signature of high-velocity atmospheric entry, tiny scorched shells from deep space. And then came the isotopic anomalies. In certain particles, the ratios of isotopes, versions of elements with different atomic weights, were just off. Not in a minor lab error sort of way, but in a "this doesn't match anything in our solar system" kind of way. That's when the whispers began. Alien materials, extraterrestrial origins, perhaps not just from space, but from elsewhere in space. Another star system, another time. Now let's not get carried away. Scientists are cautious, as they should be. Most unusual isotopic ratios can be explained through supernova residue or cosmic ray exposure, or just weird corners of the solar system we haven't explored yet. But every once in a while, a particle crosses the line into unexplained. Take the Hypatia stone, for example, not found in Antarctica, but often mentioned in the same breath. It was discovered in Egypt, but what makes it strange is that its internal chemistry doesn't match Earth's crust, the Moon, or even meteorites from Mars. Some suggest it may predate our solar system entirely, and the particles found in Antarctic ice Some show similar chemical oddities. It's like finding stardust that doesn't know which galaxy it's from. You pause for a moment and imagine it. A single particle floating through space for billions of years, untouched by planets or suns, until it gently drifts into Earth's gravity and lands silently in the Antarctic snow. No fanfare, no explosion. Just dust, settling timeless, ancient, foreign. You'd never notice it. But under the microscope, it tells a story longer than human civilization. Some of the particles found here are believed to originate from specific supernova events, stellar explosions so powerful they seeded the galaxy with heavy elements. That means you're literally holding star fragments in your hand. Iron from a dead sun, carbon from the bones of collapsing stars. And when you think about it like that, the phrase "we are stardust" isn't poetic, it's forensic. But it's not just science fiction poetry. These particles tell us things. Some may have formed in the accretion disk of a newly forming solar system. Others may be remnants of ancient planets destroyed by cosmic collisions. Each one holds a unique isotopic fingerprint, like a passport stamp from a world we'll never see. And then, of course, there are the theories that push even further. Some researchers, mostly fringe, but not always, speculate that Antarctica's unique position and magnetic field interactions might act as a kind of funnel for certain types of interstellar debris. That perhaps the poles serve as natural collectors of not just Earth-made particles, but cosmic ones. One particularly persistent theory claims that high-energy particles found in Antarctic ice cores exhibit energy levels inconsistent with known astrophysical phenomena. That is, they might not be from stars at all. Could they be artificial? The idea is controversial to the point of being radioactive in academic circles, but it persists. Proponents point to anomalies in the structure of certain micrometeorites, unusual ratios of metals, precise geometric shapes on the nanoscale, even layered composites that some liken to engineered materials. Mainstream scientists caution against jumping to conclusions. After all, nature is messy and creative. Crystals form with perfect symmetry. Impact pressure can shape metals into bizarre structures, and statistical flukes do happen. Still, you can't help but wonder if someone or something was sending messages across time and space. Would we even recognize them? Maybe the messages are too small. Maybe we've been sweeping them into jars, labeling them space dust, and locking them in cold storage, never realizing they're not just relics, they're records. You pull your goggles tighter and look through the microscope one more time. The particle under the lens is smaller than a grain of sand, older than your species, and very likely from a place beyond your sun. It's unremarkable at first, just a fleck of silicate coated in iron oxide. But then beneath that, a layer of carbon nanotube-like structures, too ordered, too perfect. The lab notes say possibly a quasi-crystal, further testing required. But you feel it in your gut. This wasn't made here, not even close. Scientists still argue whether these particles are just outliers or signposts. Are we looking at the galactic version of pollen, tiny, passive, directionless? Or are we mistaking probes for dust? The Antarctic ice preserves it all. Every century of snowfall, every rogue cosmic visitor. And it's not just frozen history, it's frozen context. The particles sit exactly where they landed, like bookmarks in the story of Earth's relationship with the universe. You step outside the lab. The stars are clearer here than anywhere else on Earth. Above you, the Milky Way stretches like a quiet question. Somewhere out there, particles are moving, drifting, searching, and someday, maybe next year, maybe 10,000 years from now, one of them will fall, gently, silently, into the white, and we'll be here to catch it. You walk now across a stretch of ice so silent, you begin to wonder if even your thoughts might echo. The air grows colder, but the light shifts pale pinks and oranges bleeding across the endless snow like a watercolor sky. In this forgotten corner of East Antarctica, there's something hidden under the ice that rewrites not only expectations, but entire timelines. Beneath your feet lies what should be impossible, a rainforest. Let's pause on that word, rainforest. Not tundra. Not a few scraggly shrubs toughing it out during some prehistoric summer, but a lush, dense, thriving rainforest ecosystem complete with ferns, conifers, flowers, and ancient trees. The kind you might expect to see in modern-day New Zealand or Chile, not thousands of kilometers inland on the most barren continent on Earth. And yet, that's exactly what was discovered near the Amundsen Sea coast, buried under nearly a kilometer of ice. In 2012, a German-British research team drilled into the seabed beneath the ice shelf. They weren't expecting much, just standard sediment samples. But what came up shocked them. Layers of ancient soil. Not just mud or sand, but peat-rich earth containing fossilized roots pollen and even fragments of forest floor. The samples were nearly 90 million years old, dating back to the mid-Cretaceous period when dinosaurs still roamed the Earth, and Antarctica was, well, not quite the place we know today. You crouch down now, pressing your hand into the snow. Imagine right where you're kneeling, there once stood towering trees, insects buzzing through thick undergrowth, freshwater streams trickling through mossy ground. There were no glaciers here, only green. It's not just poetic, it's scientific. The isotopic composition of the sediment combined with fossilized pollen and root structures tells a vivid story. This wasn't a seasonal blip. The rainforest endured for millions of years. And more than that, it thrived within the Antarctic Circle. That revelation has planetary implications. Because in order for such a forest to exist, Antarctica must have had a dramatically different climate. Carbon dioxide levels were far higher, somewhere between 1,000 and 1,600 parts per million, compared to today's 420. There were no polar ice caps. Sea levels were 100 meters higher. The average summer temperature here, around 20,068 degrees. That's like Paris or Seattle. Let that sink in. Antarctica wasn't always a frozen tomb. It was once a cradle of life. And that changes things, not just for paleobotanists or climate historians, but for anyone trying to understand how radically different the Earth once was. Because if a rainforest can exist here, what else might have once flourished beneath the snow? Historians still argue whether human civilization has ever seen a truly ice-free Antarctica. The dominant scientific consensus says no modern humans emerged long after the continent froze. But the deeper we drill, the more complicated that story becomes, because this forest predates not just humanity, but mammals. And yet, it's preserved not in amber, not in rock, but in soil. Soil that sat frozen and untouched for nearly 100 million years until a team of researchers decided to poke at the Earth's memory. What they found was not just evidence of a rainforest, but a challenge to everything we assume about permanence. Climate is not permanent. Ice is not permanent. Even the most desolate places on Earth were once something else entirely. And that brings us to the haunting possibility: if we could walk through this lost forest now, if we could unfreeze it and step back into that Cretaceous summer, what else might we find? Footprints, fossils, signs of more complex life. No direct evidence has surfaced yet, but the potential is enormous. Insects, amphibians, maybe even small dinosaurs creatures adapted to the dim polar light and warm, humid air. A rainforest that existed not just near the equator, but under months of twilight under auroras and volcanic mists. It's hard not to imagine some future expedition uncovering a preserved vertebrae. A dinosaur unlike any seen before, adapted not for bright sun, but for the muted glow of a polar year. You shake your head, breath curling in front of you. It's not fantasy, it's just waiting. Because this continent is not dead, it's sleeping. And then the whispers start. Not literal whispers, of course, but the ones that echo in forums and books pushed to the edge of academia. Some say Antarctica wasn't just home to plants. That maybe, just maybe, it hosted intelligent life. That during one of Earth's many forgotten epochs millions of years ago, another lineage might have risen, built, learned, Vanished. Is there proof? No. But the gaps in our record are enormous. We have more fossils from the deserts of Mongolia than we do from the icy underworld of Antarctica. And when you consider that nearly 98% of the continent is covered in ice more than a mile thick, it becomes painfully clear we've barely scratched the surface. If something did rise here, something intelligent, something curious, it would be buried so deeply we might never find it, unless the ice melts. And it's melting. That's what adds urgency to all of this. The warming climate isn't just a disaster, it's a revelation. As the glaciers retreat, as the shelves collapse, more ancient material is being exposed. Fossils, sediments, seeds, maybe even remnants of things we've never dared to imagine. Fringe theorists point to magnetic anomalies, satellite blurs, unexplained formations under the ice. But you don't need conspiracies to feel wonder. Just hold a piece of petrified root in your hand, dug from a kilometer below the ice, and ask, how did this get here? The answer is both simple and overwhelming. The Earth changed, and it will change again. Antarctica wasn't always white, and it may not always be. You rise now, your boots sinking slightly into the snow. In the distance, the horizon shimmers light bouncing off a frozen world that once bloomed with life. Not in metaphor, not in myth, but in green. And somewhere beneath your feet, the forest still waits. You trek farther inland now, where the silence thickens, broken only by the subtle crunch of your boots on snow. The white landscape stretches endlessly in every direction, flat, featureless, and yet deceptive. Because beneath this cold monotony, mountains sleep. Not jagged peaks you can see, but entire ranges hidden under the ice, towering as high as the Alps and as vast as the Rockies. They are called the Gamburtsev Mountains, and they are one of Antarctica's deepest, most beguiling mysteries. Discovered in 1958 during a Soviet expedition, these buried mountains immediately defied explanation. How could a range so tall and rugged, spanning 750 miles across East Antarctica, remain completely concealed beneath over a mile of solid ice? More importantly, how could they have even formed here? You might assume Antarctica's flat because, well, that's how it looks. But satellite radar and seismic imaging reveal a very different story. These aren't just rolling hills or buried ridges. The Gamburtsevs have sharp peaks, steep valleys, and the classic U-shaped canyons of alpine terrain. In fact, if the ice ever melted, they'd resemble the European Alps in their dramatic majesty. But that's only the beginning, because what really troubles geologists is that the Gamburtsevs shouldn't exist, at least not the way they do. Here's the paradox. Mountain ranges don't last forever. Erosion wears them down, tectonics rearrange them, glaciers grind them to dust. Yet these mountains are ancient, possibly over 1 billion years old, but they still look geologically fresh, not young in age, but young in structure. Their peaks are too sharp, their relief too stark. So how do mountains this old remain this crisp? Scientists still argue whether these are remnants of an even older orogeny, an ancient collision between cratons that stitched together the supercontinent Rodinia, or whether a more recent uplift event rejuvenated them. Some suspect that the massive weight of Antarctic ice has acted as a sort of preservative shielding the range from erosion for tens of millions of years. Others propose that fault lines deep below the crust have reactivated the region, pushing old rock back up toward the surface like a geological Lazarus. In short, the mountains are old, but somehow they've stayed young, which frankly shouldn't be possible. You might wonder, why does this matter? Because mountain ranges shape ecosystems. They guide weather, they store water, they influence ice flow. The very formation of the East Antarctic ice sheet, the oldest, thickest ice mass on Earth, may have been triggered by the Gamburtsevs, acting as a kind of seed. Picture this around 34 million years ago, when Antarctica began to cool dramatically. These mountains, already ancient, stood tall enough to capture moisture from the air. Snow accumulated around their peaks year after year, century after century. Eventually, this snow compressed into ice. More snow came, more compression. Glaciers formed, then merged, then deepened. And before long, the continent was locked in ice. The Gamburtsevs may have been the catalyst for an entire planetary transformation, and yet we've never seen them. No human eye has gazed upon their peaks. No climber has summited their ridges. They exist entirely through remote sensing sonar echoes and magnetic pulses. Even the most detailed maps we have are stitched together from years of aerial surveys, ice-penetrating radar, and seismic tomography. It's like mapping the outline of a ghost by watching how it bends the air around it. You stop for a moment looking out across the ice sheet. Somewhere beneath your feet, massive peaks rise like sleeping giants preserved by time and cold. And here's where things get stranger. In 2009, an international research team called AGAP Antarctica's Gamburtsev province conducted the most thorough survey yet. Using airborne instruments, they mapped the subsurface terrain in incredible detail. What they found astonished them. The range wasn't just big, it was structurally complex. Multiple fault zones, deeply incised valleys, and even hints of past volcanic activity. More puzzling. At the base of some of the valleys, there were signs of liquid water, subglacial lakes. Not unusual in Antarctica, but here, nestled between ancient peaks and fissures, they take on a new mystique. Some may have been isolated for millions of years, their microbial ecosystems evolving in secret. And as always, speculation followed. Fringe theorists latched onto the idea of hidden lakes and buried mountains. Some claimed the Gamburtsevs might conceal more than geology, perhaps ruins, or even entrances to vast underground chambers. Echoes of the hollow earth theory re-emerged, linking back to World War II-era myths about Nazi expeditions and secret bases beneath the ice. We can roll our eyes, sure, but even the most grounded scientists admit we simply don't know what's down there, because we've never drilled that deep. Yet, you imagine for a moment a future expedition standing atop an exposed Gamburtsev peak, ice-melted sky-open sunlight spilling across stone that hasn't seen daylight in tens of millions of years. Would it feel like the first climb of Everest, or something more surreal, like stepping into Earth's memory? The deeper implication is humbling. We think of Earth as fully mapped, fully known. But under this ice lies a mountain range the size of the Alps, entirely invisible to the naked eye. If something that massive can remain hidden in plain sight, what else might we be missing? You lean on your walking pole now, staring across the endless horizon. The snow reflects the pale glow of the moon, and you swear for just a second you can see the peaks, not with your eyes, but with your imagination. Rising. Watching. Maybe the Gamburtsevs aren't just hidden. Maybe they're waiting for the ice to recede, waiting for us to listen, waiting for anyone to notice just how little we really know about the ground we walk on. Because beneath the quiet, beneath the cold beneath your feet, an ancient range dreams in silence. And dreams in Antarctica don't always stay buried forever. You drift eastward now across a bleak and bitter white expanse where no wind howls and no birds cry, just the endless crunch of your boots echoing into nothingness. But this next story isn't frozen in prehistory or carved by ancient tectonics. It belongs to the shadowed corridors of the 20th century, a time of war ideology and obsession. It begins with the flickering torchlights of a lost Nazi expedition and ends in whispers of secret bases beneath the ice. Welcome to one of Antarctica's most persistent and unsettling mysteries, the alleged Nazi presence on the frozen continent. At first glance, it seems absurd. Nazi Germany, Antarctica. What could they possibly want down here? Penguins and permafrost. But the truth, as always, is stranger and far more ambiguous than fiction. In 1938, just before the outbreak of World War II, Germany launched an expedition to Antarctica aboard a vessel named the Schwabenland. Its mission, officially, to secure potential whaling grounds and territorial claims. But the ship didn't just sail, it flew. Using catapult-launched Dornier aircraft, the Germans surveyed vast stretches of East Antarctica, dropping aluminum darts bearing swastikas to mark claimed territory. The region was named Neuschwabenland. On paper, the mission ended there, just a colonial footnote. But over the years, the story mutated. Fringe theorists would later claim that the Nazis had returned this time in secret, establishing hidden bunkers, underground bases, and perhaps even advanced research facilities beneath the ice. Some suggested they fled there after the war's end, escaping justice to regroup in frozen isolation. Others pointed to supposed post-war sightings of U-boats near the South Pole, long after Germany had surrendered. The claims intensified in 1946, when the United States launched Operation High Jump, a massive naval expedition led by Admiral Richard Byrd. With 13 ships, over 4,000 personnel, and dozens of aircraft, it was one of the largest Antarctic missions in history. The stated goal was to train troops and test equipment in extreme cold. But the scope just 1 year after World War II raised eyebrows. Then came Byrd's strange comments to a Chilean newspaper upon his return. He spoke of a potential enemy that could fly from pole to pole at incredible speeds. No one knew what he meant. Perhaps nothing. But in the vacuum of uncertainty, the legends multiplied. You kneel now, brushing snow away from the side of a jagged outcrop. Imagine the conspiracy version of events. Deep beneath the ice lies a city of steel and stone, built by fleeing engineers and SS scientists powered by stolen technology or reverse-engineered devices beyond our understanding. Perhaps even something ancient they discovered here, some artifact or energy source that justified their interest in the most inhospitable place on Earth. Of course, no hard evidence has ever emerged. No blueprints, no ruins, no photographs, just stories. And yet the mystery endures. Even modern researchers have unearthed curious anomalies. Satellite scans of Queen Maud Land and other parts of East Antarctica occasionally reveal heat signatures or unusual geometric patterns beneath the ice. In most cases, the explanation is mundane rock formations, crevasses, natural insulation, trapping geothermal warmth. But that hasn't stopped speculation. There are also rumors of forbidden zones, areas off-limits, even to modern scientific expeditions. Some say they are protected to preserve unique ecosystems. Others, more conspiratorial, claim that these zones house secrets far older than the Cold War. But perhaps the most enduring reason this story won't melt away is its sheer psychological allure. Antarctica is the ultimate blank slate. A place so remote, so extreme, so invisible to the average person that any story, no matter how wild, can take root. Combine that with the dark fascination surrounding Nazi mysticism, and you've got the perfect storm of intrigue. Because it wasn't just politics and war machines. The Nazi regime also pursued occultism, esoteric history, and Aryan mythologies. Figures like Heinrich Himmler were obsessed with the idea of ancient civilizations, hidden races, and forbidden technologies. They funded expeditions to Tibet, dug for relics, searched for the Holy Grail. Is it really so hard to believe they might have turned their eyes south toward a continent untouched by modern hands? Historians still argue whether the Nazi interest in Antarctica was purely strategic or deeply symbolic. Some suggest that Neuschwabenland was meant to be a new Atlantis, a mythical refuge for the so-called master race. Others believe it was simply about resources control and long-term positioning for a global conflict. Whatever the motivation, the legend continues to mutate. In some retellings, post-war Nazis didn't just hide, they thrived. Built flying saucers, discovered ancient alien bases, formed secret alliances, hid in underground ice caverns connected by tunnels warmer than they should be. You've probably heard echoes of this in movies, comics, even internet rabbit holes. Of course, it sounds outlandish. But not all mysteries need flying saucers to unsettle you. Sometimes the real discomfort lies in how little we truly know about what happened in the remote corners of history. Records go missing, expeditions are reclassified, maps are redacted, and Antarctica, with its howling white silence, guards its truths more tightly than any desert or jungle. You rise now, glancing toward a snow-covered ridge. The sky is turning dark twilight, settling over this alien world. For a moment, you imagine shapes moving far in the distance, lights where there should be none, silhouettes against the ice wall. A trick of the cold, surely. But part of you wonders, if there were something beneath the ice, an old base, a sealed tunnel, even just the rusting hull of a long-forgotten outpost, would we even know? Would we be allowed to? Because sometimes silence is its own kind of answer. And Antarctica is nothing if not silent. You continue walking now, drawn further into Antarctica's deep interior, where the ice thickens and the air grows thinner. The surface beneath your feet is ancient layered snowfall, compressed into solid ice over millions of years. But tonight, your attention turns not to what lies atop the continent, but what bubbles quietly below. Subglacial methane reservoirs. You stop at a ridge where a recent borehole project punctured through more than a kilometer of frozen silence. The ice core extracted here, long and clear, like a ghostly spine, tells a story of fire trapped in frost. Methane. A potent greenhouse gas is being discovered in places no one expected, and in volumes no one quite knows how to explain. Methane is a flammable gas most often associated with decaying organic matter, deep ocean seeps, or industrial emissions. It is, in simpler terms, the Earth burping as it digests itself. But beneath Antarctica, where temperatures remain perpetually frozen, where no plants rot and no animals breathe, it shouldn't be present in large quantities, and yet it is. In East Antarctica alone, researchers estimate that subglacial methane deposits could rival those found in the Arctic permafrost. Some of this methane is trapped in ancient sediments, what was once swampland or seabeds, buried under kilometers of rock and ice. Other pockets may have formed through microbial life still active in briny, oxygen-starved subglacial lakes. Yes, life. Even here, you can almost hear the bubbling beneath your boots. It's not loud, of course. It's molecular, silent. A vast subterranean breath held for eons. But the implications are loud. If even a fraction of this methane were released into the atmosphere, say due to melting seismic activity or ice shelf collapse, it could trigger powerful feedback loops in Earth's climate system. Methane is over 25 times more effective at trapping heat in the atmosphere than carbon dioxide. A sudden spike could amplify global warming in unpredictable and irreversible ways. It's like sitting on a time bomb frozen in place, ticking ever so slowly. You might wonder, how is it even possible for methane to exist down here, where the temperatures are so low? The answer lies in insulation. The same thick ice sheet that makes Antarctica so uninhabitable also acts like a gigantic pressure lid. Deep beneath, geothermal heat seeps up from the Earth's mantle, warming isolated pockets just enough to support liquid water and life. In these isolated basins, ancient organic matter, dead plankton, prehistoric plants, has decomposed in slow motion, feeding microbial communities that in turn produce methane as waste. What's chilling is not just that it's there, but that it's growing. Recent seismic studies have detected rising gas pressures in some subglacial areas. In the Aurora subglacial basin and the Wilkes Land regions, yes, the same Wilkes Land, with that magnetic anomaly, there are indications of trapped reservoirs potentially nearing release. Historians still argue whether methane explosions contributed to past climate events, like the Paleocene-Eocene thermal maximum, a global spike in temperatures roughly 56 million years ago. That warming lasted over 100,000 years. Some suspect a massive methane release played a role either from clathrates under the sea or from melting tundra. Now, imagine such a release happening in our time. Not just in the Arctic, where the threat is well known, but here from the heart of Antarctica. It would be like removing a keystone from a delicate arch. Everything could shift. And yet, paradoxically, some see this trapped methane not as a threat, but as a resource. You heard that right. There are whispers of potential energy extraction operations decades down the line. After all, methane is a fuel. If the technology were ever developed to tap these reservoirs cleanly, without destabilizing the ice above Antarctica, could theoretically provide a new energy frontier. But that, of course, would require breaking the Antarctic Treaty. Since 1961, this treaty has designated the continent as a place for peace and science, a reserve for all humankind, free from military activity and resource exploitation. But treaties like ice can crack. Some nations have begun preliminary surveys mapping underground reserves and tracking volatile gases with a suspicious degree of precision. It's hard not to wonder, are we studying these reservoirs to understand them, or to one day use them? The ethics are murky, the science even more so. And then there's the deeper layer of mystery. Why are some methane pockets warmer than expected? Seismic sensors have occasionally picked up subtle tremors, deep booms, that may be linked to gas movement under the ice. Some of these booms occur in areas where no current geological explanation fits. Could there be hydrothermal vents beneath the glaciers, or even some speculate anomalous heat sources yet to be understood? We've already discovered over 400 subglacial lakes beneath Antarctica, many of them connected by secret rivers, warmed not by the sun, but by Earth's own breath. What if some of these lakes harbor more than microbial life? What if complex biochemical systems are thriving, releasing methane not as a byproduct, but as a signal? A few fringe scientists propose that methane readings could hint at unknown ecosystems, not alien, but ancient. Deep biospheres that have evolved in total isolation, shielded by ice operating on timelines entirely separate from the surface world. Others go even further. Some have drawn tenuous parallels between methane hotspots and strange magnetic anomalies, between unexplained heat flows and the outlines of supposed artificial structures detected by satellites. They suggest the methane is not just biological, but mechanical. Perhaps a remnant of something buried, something dormant. You hesitate, staring out across the emptiness. It's easy to dismiss such ideas. But here in the absolute quiet, everything feels plausible. The Earth holds many secrets, some natural, some accidental, some inherited. And Antarctica may be where those secrets gather, shielded, encased, awaiting the melt. You crouch now beside a research station's borehole. A thin metal tube disappears into darkness. From its depths, instruments relay temperature readings, gas compositions, pressure spikes. Each number is a whisper from the underworld. Methane levels rising. Subglacial pressure stable for now. Microbial activity active. And outside above it all, the ice stretches quiet, oblivious, implacable. But not eternal. You rise and look eastward. The wind picks up. The future you sense is already stirring beneath the crust. And its breath smells faintly of methane. You wake to a stillness so complete it feels carved from stone. The Antarctic wind has gone, leaving behind only the rhythmic creak of ice under your boots as you descend a narrow trail between research markers. You've seen magnetic anomalies, hidden forests, and ghostly mountains. But this next discovery, it hums with something more elusive. Not geological, not political, not even necessarily biological. It's architectural. Or so some would argue, because here in the frozen region of Wilkes Land, scientists have detected something unnerving, buried deep beneath the ice, a dome-shaped mass stretching more than 150 miles in diameter, showing signs of heat gravity, anomalies, and structural symmetry. You pause, recheck the numbers. A perfect circle warmer than its surroundings rising from the bedrock, like an echo of something constructed. The headlines were swift. Some sensational, some sober. Ancient civilization buried under ice alien base in Antarctica. But beneath the clickbait lies a quieter, more compelling truth: we don't know what it is. And when science whispers, we don't know, you know you're close to something worth listening to. Discovered in 2006 using satellite gravimetry, this Wilkes landmass anomaly doesn't show up in visible light or radar. It's only through shifts in gravitational pull, how satellites wobble ever so slightly as they pass overhead, that scientists mapped its rough contours, like a shadow in the Earth's fabric, only detectable by the way it bends the space around it. Some believe it could be the remnant of a massive asteroid impact, possibly one responsible for the Permian-Triassic extinction event 250 million years ago. That event wiped out over 90% of all life on Earth, our planet's most severe extinction event on record. If true, the impactor would have been more devastating than the one that killed the dinosaurs. We're talking a crater hidden beneath kilometers of ice, its trauma etched into the planet's crust like a scar under a bandage. But then there's that shape, too round, too smooth, and oddly too warm. The central part of the anomaly seems to emit heat not enough to melt the ice above, but enough to be statistically significant. Combined with strange gravitational readings, this has led to speculation far outside conventional geology. You sit now on the edge of the drilling site, watching technicians prepare a new borehole. It's slow work melting through solid ice with sterilized hot water drills, hoping not to disturb whatever lies beneath. Some whisper of pyramids buried in the ice. Others of massive domes vaults from a time before history. Could it be possible that Antarctica, in some unimaginable age, housed a civilization, one capable of monumental construction? Not just tents and tools, but megaliths. Historians still argue whether humanity's timeline is truly complete. New discoveries constantly push back our estimates of when cities' agriculture, even writing, first emerged. Göbekli Tepe in Turkey was built 12,000 years ago, when humans were supposedly still hunter-gatherers. What else might have existed and been erased before that? And what better place to erase something than here? In the Antarctic interior, no weeds grow, no roots spread, no flood washes debris away. If a structure were buried by snow and ice 10,000 years ago, it could remain untouched today, frozen in situ, perfectly preserved. Imagine walking through that structure now. Walls of black stone humming faintly under gloved hands. Corridors coated in frost doors, half-collapsed mosaics hidden beneath rime. Light filtering in through crystalline ceilings, catching on glyphs no human being remembers how to read. Too fanciful. Then, let's return to what we do know. Core samples taken near the Wilkes Land anomaly have shown unusual magnetic disturbances and mineral compositions inconsistent with surrounding formations. Deep ice radar sometimes registers angular formations, where there should be none, like edges and corners beneath hundreds of meters of glacial insulation. And then, there's the sonar echo's strange bouncing signals detected during seismographic studies. Not random, not natural. Some patterns suggest chambers or hollows, too regular to be caverns, too structured to be coincidence. But again, these are readings, not revelations. No one's touched the object. No one's seen it with their own eyes. Yet. And that leaves the door wide open. You shift your gaze upward now as clouds scatter and the sky reveals its ancient face. If something lies beneath that ice civilization machine memory, what story would it tell? Was it human? Something before us? Or something not from here at all? Some fringe theorists, of course, leap to the stars. They connect the Wilkes Land anomaly with the ancient astronaut hypothesis, speculating that early advanced beings, whether alien or ultra-terrestrial, could have chosen Antarctica as a base. Remote, shielded from interference, and geologically stable for millennia. You may not buy the theory, but you can't deny the psychology. Antarctica is the closest thing we have to another planet on Earth. It's cold, lifeless, unexplored. Anything could hide here. And the most compelling part, every year the ice thins. Every decade new technology peels back another layer. Eventually someone will dig deep enough, long enough with just the right instruments, and the anomaly will be revealed. Maybe it's a crater, maybe it's a trick of gravity, or maybe it's a doorway. one that leads not down, but backward into a version of Earth we've never imagined. You rise again, gloved hands brushing snow from your knees. Your breath curls in the air like smoke from an ancient fire. Somewhere beneath your feet, the ice whispers secrets. And you, just one more visitor in a long, silent line, keep walking. Because what waits below is not legend. It is real, just not yet visible. You pause at the edge of a survey station, now long abandoned its steel ribs, protruding from the snow like a shipwreck trapped in a frozen sea. The silence presses in again, but this time it's different, heavier. You feel it as a pulse deep beneath your feet, as if the earth itself is murmuring through layers of ice. Because in the vast frozen emptiness of Marie Byrd Land, there's something beneath the ice that no one can quite explain. A heat source, but not just geothermal warmth seeping up from the mantle. This is something hotter, something more focused, something odd. We're talking about the anomalous heat source beneath Marie Byrd Land, a region in West Antarctica, so remote it has no permanent research stations and lies outside any official national claim. It's about the size of Texas and has long been one of the least understood parts of the continent, until scientists began noticing strange things, starting with the radar surveys. In 2017, scientists from the University of Colorado and NASA began publishing data showing an unexpectedly high geothermal heat flow in this region. That means the ground under the ice is warmer than it should be. Much warmer. We're not talking tropical temperatures, but we are talking enough heat to rapidly melt ice from beneath, forming subglacial lakes, accelerating glacial movement, and possibly weakening the entire West Antarctic ice sheet. But the strangest part, this heat source is not volcanic. Let's be clear, Antarctica has volcanoes, dormant ones, active ones, and even one currently covered by a thick glacier, Mount Erebus. But the heat beneath Marie Byrd Land doesn't behave like volcanic activity. There are no magma chambers, no plume signatures, no seismic patterns typical of a volcano. Instead, it's a diffuse heat flow concentrated in an area that on paper should be geologically quiet. So where is the heat coming from? That's the question keeping researchers up at night. One theory suggests a mantle plume, an upwelling of unusually hot rock rising from deep within the Earth's interior, much like the one that created the Hawaiian Islands. But that theory doesn't quite fit either, because the heat is too localized and too shallow. There's no definitive evidence of a plume reaching up into the crust. Another possibility involves radiogenic decay, natural heat, generated by the breakdown of radioactive elements like uranium and thorium in the bedrock. But again, this usually occurs in stable continental crusts. Antarctica's crust here is thinner and geologically active in ways we don't fully understand. The amount of radiogenic heat required to account for the anomaly seems excessive. Historians still argue whether this heat source is a new phenomenon or one that's simply been hidden until our instruments caught up. But whatever it is, it's changing the ice. It's causing subglacial lakes to form and drain in pulses. It's destabilizing the foundations of glaciers that feed into the Amundsen Sea, one of the fastest changing regions in the entire cryosphere. If this heat continues or increases, it could potentially lead to accelerated ice loss and sea level rise around the globe. But beyond the science lies something stranger, because this isn't just any part of Antarctica. Marie Byrd Land has long been associated with anomalies. It's where magnetic readings behave oddly. It's where pilots have reported compass failures. It's also home to some of the continent's deepest subglacial valleys, hidden mountain ranges, and unexplained radar signatures. If you're going to pick a place for Earth to hide something ancient, something powerful, or something forbidden, Marie Byrd Land is as good a guess as any. Some theorists go further. They point to the presence of symmetrical formations under the ice radar reflective shapes that suggest artificial geometry. Could these be buildings, ruins, or entrances? Others note the proximity of the heat source to seismic blinking zones, areas where tremors occur in patterns that don't align with tectonic norms, as if something deep beneath the surface moves. Fringe thinkers love this kind of ambiguity. They argue the heat source isn't natural at all, but a power source perhaps left by an ancient race, or even by beings not of this world. A few claim that the heat isn't heat at all, but radiation from a buried object. Something humming quietly in the deep, something not dead, just dormant. Of course, mainstream science rolls its eyes, but here's the thing: scientists agree that we don't fully understand what's happening in Marie Birdland. The geothermal anomaly is real. Its impact on the ice sheet is measurable, and whatever is generating that heat, it's stable, sustained, and possibly growing. You stand now at the edge of a borehole from a recent drill. It descends over 1,000 meters, a dark, smooth-walled tunnel melted into the glacier. Instruments dangle deep within reading temperature, seismic movement, and radar pulses. The temperature spikes at the bottom, not enough to suggest magma, but far too high for a continent locked in eternal winter. Some researchers suggest that this area might represent a transition zone where ancient geological activity is reigniting due to pressure changes, ice melt, or even tidal forces from beneath the crust. There's a theory called true polar wander, which suggests the entire crust of the Earth can slowly shift over time. If that's happening now, even subtly, it could explain increased heat flow in formerly dormant regions. But that only deepens the mystery. Because if the heat is moving, what else is moving with it? You glance out across the blinding white. Nothing stirs, nothing speaks. But beneath you, the Earth may be shifting in its sleep, rearranging pieces of a puzzle we haven't even finished laying out yet. And you wonder what happens when the ice is finally gone, when the last barrier between us and what lies beneath is broken. What will we find? A geological oddity, or the memory of something far older than we've dared to imagine? A city swallowed by snow, a vault of forgotten knowledge, a power source meant to remain untouched. You don't know, no one does. But the heat keeps rising, and the silence above grows thinner with every melting year. The landscape changes again, becoming strangely familiar, like something from another world, and yet eerily Earth-like. You descend from the higher ridge of Marie Birdland into a realm where snow stops falling and the wind rarely howls. Here, the air is sharper, the sky a little too clear. There are no snowdrifts, no ice walls, no crevasses. Welcome to the dry valleys of Antarctica, a paradox wrapped in silence. These valleys, Taylor, Wright, Victoria, and others, are some of the driest places on Earth, despite being surrounded by the largest concentration of freshwater ice on the planet. Some areas haven't seen rain or snow in nearly 2 million years. That's not a typo. And it gets stranger despite air temperatures that regularly drop below 50 degrees. There's almost no ice on the ground here. Why? Because of a phenomenon called katabatic winds, cold, dense air from higher elevations that flows downhill under the force of gravity. In the dry valleys, these winds can reach hurricane speeds and have such low humidity that they sublimate ice, turning it directly from solid to vapor, bypassing the liquid phase entirely. Over time, they've stripped the valleys of snow and left behind a stark Martian desert. You're walking through one of the only parts of Antarctica where the ground is visible, where you can kneel and touch rocks not covered for millennia. It's dusty, crumbly, rust-colored soil, the kind of terrain you'd expect on Mars, which is why, of course, NASA comes here to train and to test. The dry valleys are Earth's closest natural analog to the Martian surface. It's not just about the look, it's the environment. No rain, minimal life, harsh UV radiation. And yet, even here, life persists. In 2009, scientists discovered microbial mats beneath a shallow lake in the dry valleys, Lake Untersee. These microbial communities survive without sunlight, oxygen, or nutrients from the surface. They metabolize sulfur and iron, forming slimy colonies that resemble stromatolites, some of the oldest life forms on Earth. And here's where things get wild. These microbes aren't just surviving, they're thriving, evolving, adapting in real time. Some even possess DNA repair mechanisms that rival any known extremophile. In the Dry Valley's soil, researchers have found dormant bacteria and fungi that wake up after being rehydrated even after thousands of years in stasis. It's a microbial Lazarus effect. Historians still argue whether these life forms are remnants of older Earth ecosystems, or if they represent entirely unique biospheres shaped in isolation by millions of years of cold and desiccation. And the implications for astrobiology are profound. If life can survive here without liquid water, without sunlight, in the constant presence of extreme radiation, then the possibilities for life on Mars, Europa, or Enceladus increase dramatically. That frozen red desert you've seen through a telescope, it might be sleeping, not dead. Which brings us to the valley's most famous anomaly, the Blood Falls. You reach the mouth of Taylor Glacier, where a blood-red streak oozes from the ice like a wound. No, it's not iron oxide paint or dye. It's a briny subglacial outflow rich in ferrous iron, which oxidizes upon contact with air and stains the ice a deep crimson. It looks like the glacier is bleeding. But it's what lies beneath the Blood Falls that's truly astonishing. A sealed subglacial lake cut off from the surface for millions of years contains a thriving ecosystem of extremophils which metabolize iron and sulfur in complete darkness. No oxygen, no sunlight, just chemical energy processed in ways we still don't fully understand. Some researchers believe these microbial metabolisms mirror what ancient Earth life would have looked like billions of years ago before photosynthesis. Others think they offer a preview of life's final form, what might remain after the sun burns out and Earth returns to ice. Either way, it's humbling. You crouch near the rusty cascade, the only sound the soft drip of water slowly freezing again in the cold. The sight is unnerving, a glacier weeping red into a lifeless land. And yet the place is full of life. Not in the way we usually define it, no deer, no moss, no bees. But life at its most elemental, its most tenacious, even under the rocks. Yes, under there are endolithic organisms, tiny microbes that survive in narrow pores of stone using the warmth of sunlight that penetrates just millimeters deep. They've adapted to such extreme desiccation that they don't even need water in liquid form, just vapor and trace amounts of dew that condenses during brief thaws. And then there's Lake Vanda, another lake in the dry valleys covered by thick ice but hiding warm stratified waters beneath. It's not boiling, but it is significantly warmer than the surface, likely due to geothermal energy and a high salinity that traps heat. Layers of microbial life thrive at each depth level, stacked like a living history book. Some believe lakes like Vanda and Untersee offer the closest analogs we have to what extraterrestrial oceans might look like, layers of chemistry, light, and life forming independent from the atmosphere. But there's also something quietly spiritual about this place. You're walking across land that time forgot, yet life remembers. Not as forests or birdsong, but as stubborn little cells clinging to rocks, whispering the words of evolution in every amino acid they express. And despite all the high-tech instruments and million-dollar labs, we still don't fully understand how they're alive. Or why. Maybe that's the final mystery of the dry valleys, not how life survives, but why it chooses to. You rise, brushing dusty ice from your glove, and glance down the valley floor, miles of flat reddish-brown terrain stretched like an open page. This is a place where Earth has peeled back its skin, where ancient processes are still exposed, and where, if you're very quiet, the wind might carry not just dust, but memory. A memory of a planet far more complex, far more resilient, and far more mysterious than we're taught to believe. And you wonder, if life can endure here, what else might it have survived? Beneath the ice, beneath the ground, or maybe long before us. The air is shifting now, thinner. You can feel it in your lungs, a crispness, a clarity, a sense of entering a place not meant for breath. Ahead, a tunnel yawns open beneath a slanted wall of ice, and a faint luminescence pulses from within. Not light exactly, more like a glow, an echo of something alive. You step inside and the world changes. Welcome to the gigantic blue glowing ice caverns of Antarctica. These are not mere crevasses or wind-sculpted hollows. These are vast cathedral-like spaces, domes of transparent ice, tinted shades of blue so deep they seem painted by silence itself. They're formed when glacial ice stretches and bends over uneven bedrock or subglacial rivers, creating air pockets and voids where light behaves like a visitor from another dimension. When sunlight strikes the ice at just the right angle, it refracts through centuries of compressed snowfall, each layer squeezing out air, realigning crystals, filtering wavelengths until only the deepest, dreamiest blues survive. It doesn't look real. It looks holy. You pause beneath one such dome, now the ceiling arched 50 feet above, like a cathedral made not by hands, but by pressure and time. There's a stillness here that hums in your bones. You can hear your own heartbeat. But these caverns are not just beautiful. They are alive in a strange, slow-motion kind of way. Within the deepest chambers, researchers have discovered frozen gas bubbles, tiny, ancient pockets of atmosphere trapped for tens of thousands of years. By studying the chemical composition of these bubbles, scientists have pieced together the history of Earth's climate like chapters in a frozen diary. Some bubbles date back to the last glacial maximum about 20,000 years ago. Others go back further, over 800,000 years. Oxygen levels, methane content, dust particles from distant deserts, they all tell a story. Of volcanic eruptions, of forest fires in Africa, of ancient droughts in Asia. Historians still argue whether the patterns in these bubbles can predict our future climate. But the fact remains, Antarctica holds our history in its breath. And then deeper still, where even the blue fades to black, you reach the places that don't quite make sense. Caves where instruments fail. Readings spike and dip inexplicably. Microphones pick up subharmonic rumbles too deep for human ears. Some chalk it up to ice shifting. Others aren't so sure. There are stories whispered among glaciologists and expedition medics of the hum, a low-frequency vibration that pulses through certain ice caverns at night. Not constant, not mechanical, but rhythmic, almost biological. Some say it's the glacier breathing. Others say it's the Earth dreaming. But a few suggest the impossible, that something under the ice is still moving. You walk now through one of the lower caverns, your headlamp barely piercing the darkness. The walls glow faintly biofluorescent. Perhaps some microbial colonies have been found in these caves, living on mineral deposits, producing faint chemoluminescence as a byproduct of metabolism. Yes, life in the ice. In 2014, scientists discovered microbial mats living deep inside glacial caves on Mount Erebus, feeding off sulfur and carbon dioxide, isolated from the surface for centuries. The implications are staggering. These life forms are metabolizing without sunlight, surviving only on chemical reactions, chemosynthesis, just like deep-sea vent creatures. Here in these silent blue halls, alien life doesn't look so alien anymore. Because if it can happen here on a cold, dead continent under miles of ice, it can happen anywhere. Europa, Enceladus, Titan. You touch the wall. It's colder than death, yet oddly smooth. The pressure here is immense. The silence unnatural. It's the kind of place that makes your thoughts echo, where time doesn't pass so much as pause. But there are stranger reports still. Some expedition members, rare, reluctant, and always off-record, speak of lights, flickers in the corner of the eye, glows that vanish when approached. A few blame hypoxia, others reflection. But some swear the light came from within the ice. Not sunlight, not headlamps, something else. Could certain ice caverns be harboring natural electrical phenomena? Piezoelectric effects caused by immense pressure on quartz veins? Maybe. Or are the lights a form of static discharge like the eerie St. Elmo's fire sailors used to report at sea? No one knows. No one stayed long enough to find out. Because these caves, ethereal as they are dangerous. They can collapse without warning. Their ceilings shear under stress. Their floors crack open to reveal sudden drops into glacial rivers or pressurized ice. Venturing too deep without anchors, GPS, and absolute silence is a death sentence. Radios don't always work. Compasses spin. Even echoes get strange. There are documented instances of sound behaving oddly. Hear echoes that return not after a second, but after several. Echoes that don't mirror the original sound. One researcher described hearing their own footsteps a full 5 seconds after they'd stopped walking. Another described hearing breathing that wasn't theirs. It might be nothing. It might be everything. And so for now we send instruments, drones, seismometers, heat probes. We lower them into the ice like offerings asking it to speak. Some come back, others don't. And while we wait, the caverns remain, untouched, unmeasured, unequaled. They are cathedrals built by pressure, temples with no priests, archives of the oldest breath the planet has ever taken. You kneel your fingers brushing ancient ice, and you wonder what has this place witnessed, what forgotten storms, what wandering stars, what civilizations above now vanished, and what might it still remember? You don't have the answer, but the cavern does. It just hasn't decided to share yet. You're deep now, so deep that even the most persistent winds no longer touch you. The ice is dense, compacted over thousands of years into something closer to crystal than snow. As you move through another passageway in this subterranean world, you come upon something rare, precious, and perhaps even extraterrestrial. A black shard gleaming faintly in the torchlight. You found one of Antarctica's greatest gifts to science, a meteorite. Antarctica is the world's best meteorite collector, not because more meteorites fall here, but because the ones that do are easier to find. In the dry, wind-swept expanses of the continent, dark rocks stand out starkly against the snow, untouched by plant life erosion or the trample of feet. And because ice flows slowly toward mountain ridges, meteorites that fall anywhere across the continent are eventually transported to the surface of blue ice fields, where they can be picked up intact like fossils delivered by glaciers. Since the first major meteorite expeditions in the 1960s, scientists have recovered over 25,000 space rocks from Antarctica. Each one is a time capsule offering a glimpse into the birth of the solar system and sometimes into the secrets of life itself. You kneel beside this one, brushing off the frost. It's small, perhaps the size of your fist, but heavy with a dark pitted fusion crust. That crust formed when the meteorite blazed through Earth's atmosphere, melting the outer layer before it slammed into the ice. But it's what lies inside that matters. Many Antarctic meteorites come from the asteroid belt, the leftover rubble from the formation of planets. Others have been traced back to the Moon or Mars, thrown into space by ancient impacts, and flung toward Earth like cosmic postcards. We've even identified Martian meteorites with traces of water organic compounds, and most controversially, microstructures that resemble fossilized bacteria. Yes, fossilized bacteria. That was the claim in 1996, when scientists at NASA published a paper on ALH 84001, a Martian meteorite found in Antarctica. Inside its carbonate globules, they saw tiny worm-like structures, microscopic filaments and ovoids that looked suspiciously like the remnants of microbial life. Historians still argue whether those structures were really fossils or just oddly shaped minerals. The scientific community remains divided, with some pointing to contamination or natural geological processes. But for many, it was the first plausible hint that life once existed beyond Earth and that the evidence might have landed right at our feet. You lift the meteorite, feeling the weight of stardust and silence, somewhere between 4 and 4.5 billion years old. older than any rock on Earth, older than the moon even, a remnant of the chaos before the planets were born. And now it's just here, lying in the snow, waiting. This place, this frozen continent, is like a museum of the universe. No tectonic plates to grind meteorites into dust, no rain to erode them, no vegetation to bury them. Just time and ice preserving each one in near-perfect stasis. The search for these stones is more than academic. Meteorites hold clues about the building blocks of life. Amino acids, carbon chains, and nucleobase precursors have all been found inside them. These are the ingredients that, when combined under the right conditions, might give rise to living cells. And so the question lingers, did life originate here on Earth, or did it arrive from the stars? You walk now among the blue ice fields of Allen Hills, where dozens of meteorites were found clustered like coins at the bottom of a celestial wishing well. Each stone here tells a different story. Some are chondrites, unaltered relics of the early solar system. Others are achondrites melted and reshaped by heat. A few are even iron meteorites, their interiors composed of nickel-iron alloys forged in the hearts of shattered planetary cores. Imagine that you're holding a piece of a destroyed planet, a fragment of a world that never made it, a survivor. And then, of course, there are the micrometeorites, billions of them, too small to see with the naked eye, but present in every snowflake. Antarctica's snow contains an astonishing concentration of cosmic dust, tiny flakes of iron silicate and carbon drifting down through Earth's atmosphere like glitter from space. Scientists dig trenches, melt vast volumes of snow, and filter out these particles, grain by grain. Each one takes a journey of millions of years. Some formed around distant stars. Some contain pre-solar grains particles that predate our sun by billions of years. And here they are, nestled quietly in Antarctic ice, waiting to be studied. But there are stranger discoveries too. In 2013, a team found a meteorite with microscopic diamonds, not lab-grown, but natural, formed by extreme pressure. These tiny diamonds likely came from inside a long-lost planet, crushed and scattered in the violent birth pangs of our solar system. And in 2021, researchers identified an unusual carbon-rich meteorite with compounds that hinted at complex organic chemistry never seen before. Some even whisper about a meteorite, never publicly confirmed, that emitted low-level radioactive signals inconsistent with natural formation. A manufactured object, an ancient probe. The stuff of science fiction. Perhaps, but out here with no lights, no cities, and no borders, who's to say what's possible? You stare down at the meteorite in your gloved hand. Somewhere out there, an asteroid still tumbles silently in the void. Somewhere else, a dying star flares its last. And here, in the coldest place on Earth, you're connected to it all through this stone, this shard, this cosmic breadcrumb. It's humbling. It's terrifying. It's beautiful. You place the meteorite gently back into its protective case. Tomorrow, it'll be shipped to a lab, examined, cataloged, named. But for now, it belongs to the ice again, to the wind, to the story. And you walk on, because there are more stones waiting, more whispers in the snow, more proof that Antarctica isn't just Earth's last frontier. It might also be its oldest memory. The wind dies down again as you trek deeper into the white wilderness, though it's hard to tell whether it's the weather calming or your own ears growing numb to sound. The white stretches endlessly in every direction until something moves. Just a flicker, a wobble in the periphery. No, not something moving, just a feeling. Something off. You plant your boots more firmly now, instinctively adjusting your pack. Because you've reached one of the most baffling anomalies recorded on this continent, an invisible oddity not seen by the eye, but felt through mathematics and gravimeters. This is the story of strange gravitational fluctuations detected in Antarctica. On paper, gravity should behave consistently. The Earth, while not perfectly round, exerts its pull on mass in predictable ways based on density, elevation, and latitude. But in some regions of Antarctica, particularly around West Antarctica and Marie Byrd Land, the force of gravity appears to dip slightly like a silent exhale beneath your feet. That's right. Satellites and ground-based instruments have detected areas where gravity is lower than expected. Not enough to lift you into the sky or make you feel weightless, but enough to make highly sensitive instruments scream for answers. The anomaly is sometimes referred to as the Wilkes Land Gravity Anomaly, and it overlaps suspiciously with a massive subglacial structure, possibly a crater, possibly a buried mass, possibly something else. The anomaly was first seriously mapped in 2006, using data from NASA's GRACE satellites, which track tiny variations in Earth's gravitational field by measuring the changing distance between two orbiting satellites. Think of it like celestial echolocation, but instead of mapping sound, they map the mass beneath the Earth's surface. And over Antarctica, something was missing. A depression in gravity far larger and deeper than anyone expected. Now there are conventional explanations. The most cited is a massive impact crater, perhaps from an asteroid 300 miles wide that struck Earth around 250 million years ago. If true, it may have played a role in the Permian-Triassic extinction event, the largest extinction in Earth's history, wiping out over 90% of marine life and 70% of land species. Imagine that. An asteroid big enough to tilt Earth's axis, alter its orbit, and make gravity itself hiccup, and we're only just discovering it now under miles of ice. But other scientists argue against this theory. They point out that there's no definitive impact structure, no central uplift, no clear ejecta ring. So if not an asteroid, then what? Historians still debate whether the gravity anomaly could be caused by a dense mass buried deep in the crust, a type of geologic intrusion, or metal-rich core remnant. Others suggest ancient tectonic subduction zones, where one plate sank beneath another, leaving a hollow behind. And some fringe theories, well, they go further. They ask, what if it's not natural at all? That the dip in gravity corresponds to a vast subterranean cavity, a hollow expanse large enough to cause regional fluctuations in mass. A structure, a bunker, a vault. You stop and press your boot into the snow. It gives a little more than expected. Could you be standing on a roof? It sounds ridiculous, until you realize how little we truly know about what lies beneath Antarctica. The ice here is over 3 miles thick in places. Radar mapping has revealed hidden lakes, rivers, mountain ranges, and entire valleys no one's ever seen. Who's to say what might rest beneath that veil? There's a story that circulates among glaciological circles, unpublished, always anecdotal, about a survey drone that disappeared near one such anomalous zone. No signal loss, no crash, just vanished. Instruments stopped, telemetry flatlined. Recovery team found nothing. Just the drone's last transmission, which read somewhat cryptically, altitude error gravity mismatch. Of course, that could be a bug, or a joke, or a glitch in the matrix of real-time positioning data. But still, you think about it sometimes. You think about it now. And then there's the strange effect gravity anomalies have on water flow. In some parts of West Antarctica, subglacial lakes drain and refill in puzzling cycles not linked to the seasons, but possibly to subterranean shifts in pressure or mass. Could gravity fluctuations be affecting how water moves beneath the ice? Or more provocatively, could something be moving beneath the ice, altering the gravity as it goes? Some seismologists have noted ice quakes near these zones, deep tremors that don't fit normal glacial movement patterns. Some happen at regular intervals, some don't. And while we're on the subject, let's talk temporal anomalies. Yes, time. Some researchers, particularly those involved in early GPS calibration studies, reported inconsistencies in satellite clock synchronization when flying over certain parts of Antarctica. Not large, not dangerous, but enough to raise eyebrows. One explanation involves gravitational time dilation. According to Einstein's general relativity, time runs slightly slower in regions of stronger gravity. Conversely, it runs slightly faster in weaker gravity. It's measurable with atomic clocks. And in parts of Antarctica, the clocks drift in ways that don't quite line up with expectations. Could just be instrumentation error, could be recalibration lag. But it's enough to make you wonder in this strange frozen realm, is time itself behaving oddly? You pause and sit on a ridge of blue ice, your breath frosting in front of you. If you dropped an object here, would it fall a little slower? If you shouted, would the echo bounce back with a slight delay? You won't feel the difference, but the instruments do. And that's what matters, because Earth is not uniform. Its gravity wobbles, its time pulses, its crust breathes in ways we barely understand. And here in this least hospitable corner of the world, those irregularities are pronounced and persistent, and possibly pointing to something beneath the ice that's distorting everything around it. So is it a crater? A collapsed magma chamber? A buried city? A veil between worlds? You don't know, but as the sun dips behind the glacial horizon and the sky bleeds orange, one thing becomes clear. The ice here is not just frozen water. It's a lens bending light-sound gravity, and perhaps even memory. You rise, brush the snow from your knees, and take one last look at your instruments. The gravimeter flickers once, then levels off. You note the dip, mark the coordinates, and walk on. Not because you've solved the mystery, but because the mystery is walking with you. As the temperature drops and your breath fogs into little clouds that vanish almost as quickly as they appear, you feel a shift beneath your boots, not seismic, not dramatic, but subtle. The kind of shift that makes you question if the ground moved or if your senses are just playing tricks again. But this is Antarctica, and Antarctica has a way of toying with perception. Tonight's mystery lies not in the cold or the wind, or even in the sprawling silence, but in the shape of the ice itself. We're talking about hexagonal ice patterns, massive satellite-visible geometric shapes that appear across the Antarctic landscape with almost mechanical precision. From above, they resemble the tiled floors of some forgotten cathedral. Perfect hexagons, some nearly a kilometer across, etched into snowfields and icy plateaus. No machine carved them. No expedition team laid out these patterns. And yet, they persist, appearing in radar and optical satellite imagery over the past decade like a quiet fingerprint left by nature, or something else. At first glance, the phenomenon sounds simple: ice cracks, ice forms patterns. But these aren't your typical polygonal frost patches or surface ridges caused by weathering. These are deep structures often linked with subsurface geological activity, and they aren't random. The hexagonal shapes display a form of spatial organization that suggests internal dynamics, subglacial forces pushing upward in symmetric bursts, then freezing into place. Some researchers propose that these patterns are formed by thermal contraction. As ice sheets cool, stresses build and cracks form. The result sometimes is a honeycomb of fractures, like frozen lava fields in Iceland or basalt columns in Northern Ireland. Except those are formed in rock. Here it's ice doing the work, thick, ancient, moving ice. And there's more. Some of these hexagonal zones align with anomalous radar reflections. That means, under the surface, something is echoing signals back differently, be it due to density changes, mineral inclusions, or cavities. Historians still argue whether these reflectors represent natural formations like brine pockets or frozen meltwater, or whether they suggest structured voids, perhaps the remnants of geologic activity we don't yet understand. Some of the readings resemble those found in lava tubes on Earth, and even on the Moon. You walk slowly now across one such field, the hexagonal outlines faint, but traceable like ghostly sidewalk tiles. Your boots press into the grooves between panels of ice. You stop and kneel, brushing away the top layer to reveal the faint sheen of refrozen melt beneath. In some places, the lines are so clean you'd swear they were drawn. But no hand made these. Or did it? Fringe theorists propose an even more radical idea that the hexagonal fields are ancient terraforming scars, signs of long-lost human or non-human activity beneath the ice. They argue that the repeating geometry and radial symmetry are unnatural in scale and placement. To them, this is no accident of thermal stress. It's architecture. Of course, that theory is laughed off by most scientists. But then again, so was the idea of ancient bacteria surviving in subglacial lakes, or of entire ecosystems flourishing in the dry valleys. Antarctica has made a habit of proving the impossible not so impossible. And let's not forget that hexagonal symmetry is found throughout nature, from beehives to snowflakes to Saturn's polar storm. Yes, you heard that right. Saturn's North Pole features a persistent hexagonal jet stream, a rotating weather pattern thousands of kilometers wide, forming an unnaturally sharp six-sided shape. Could similar dynamics be at play here under the ice? There's another idea: acoustic patterning. Some physicists suggest that the hexagonal patterns could be the product of vibrational resonance frequencies that ripple through the ice from deep earthquakes or internal earth rhythms, leaving standing wave patterns in the structure itself. A kind of frozen Chladni plate, if you will. That would mean Antarctica isn't just a passive witness to Earth's activity, it's recording it. Visually. Like a drumhead stretched over buried drums, the ice vibrates with ancient tones, shaping itself to the beat of the unseen. You pause to listen. There's no music. But there's a pressure, low throbbing, like being underwater without sound. Your radio crackles faintly, not with a voice, but with a pulse. You double-check your instruments. Nothing's malfunctioning. Nothing's out of the ordinary. Except everything is. The hexagonal fields seem to appear most often near subglacial lakes, hidden bodies of water trapped beneath the ice sheet. This suggests a correlation. Some researchers propose that as geothermal heat warms pockets of water below pressure, builds subtly warping the ice above into symmetrical patterns. Over centuries, these patterns may rise toward the surface like tree rings pressed against a shrinking bark. But then, if it's just heat and pressure, why hexagons? Why not random cracks or chaotic ridges? Because hexagons are efficient. They cover space evenly without gaps. They're stable under stress. They're nature's go-to shape when systems seek balance under constraint. So maybe that's all this is. Nature optimizing itself. Ice seeking equilibrium. Or maybe this place is remembering. Remembering flows of water long stilled. Remembering structures that once stood, whose weight still echoes faintly through the crust. Remembering a design too old, too vast, too buried for us to understand. You rise and walk slowly to the center of the nearest hexagon. You turn in a slow circle, watching the pattern extend in every direction, like an ancient map whose language you've forgotten. And you think, what if this isn't just a phenomenon? What if it's a message, not from aliens or gods or lost civilizations, but from Earth itself? A way for the planet to inscribe its trauma, its cycles, its memory into a geometry we can almost recognize, but not quite interpret. Not yet. Because maybe one day when the ice has melted and these shapes lie exposed under open skies, someone will walk these paths and finally understand what Antarctica was trying to say. Until then, you keep walking, one hexagon to the next, one question after another. Because in this land of silence and shape, sometimes the patterns speak louder than words. The ice is older here. Not just old in a statistical sense, like hundreds of thousands of years old, but visibly ancient. It looks different under your feet. Thicker, denser, almost glassy in some places. You can see it in the way light refracts off the surface. It doesn't just shimmer, it warps, like you're walking over frozen time. And perhaps in a way you are. Because now we step into one of the strangest and most perplexing enigmas Antarctica has ever revealed, one that doesn't appear on every map and barely appears in textbooks. You've come to the realm of bizarre crater-like structures under the ice, discovered not by sight but by radar. LiDAR and gravimetric scans, these massive subglacial features don't rise above the landscape, they sink into it. Giant depressions, some spanning dozens of miles across, with oddly symmetrical rims and central peaks. To the untrained eye, they appear almost identical to known meteor impact craters elsewhere on Earth, like Chicxulub in Mexico, which famously ended the reign of the dinosaurs. Except these Antarctic craters raise more questions than answers. Some of them lack the definitive smoking gun signs of meteorite impact. There's no iridium layer, no shocked quartz, no melt rock ejecta that we'd expect from a high-energy collision. And yet, the shape is undeniably crater-like, circular, multi-ringed, too perfect to be dismissed as random. So what formed them? Well, scientists have theories. One possibility is that they are impact craters, but ones that struck so long ago that their telltale signs were erased or buried by shifting ice and time. That's plausible. Antarctica has been glaciated for millions of years. An impact that hit before the ice fully formed could have been covered and sealed away, leaving only a faint depression in the ice sheet to mark its presence. In 2018, radar imaging suggested the existence of a crater over 300 kilometers wide beneath the ice of Wilkes Land, roughly twice the size of the Chicxulub crater. If that was in fact caused by a meteor, it would have been one of the largest impacts in Earth's history. Some have even suggested it could be linked to the Permian-Triassic extinction event when over 90% of life on Earth perished. But again, no conclusive evidence. Historians still argue whether these formations are craters at all or whether there's something stranger. Subglacial volcanic calderas, perhaps massive sinkholes caused by geothermal activity, melting basal ice, or tectonic domes that collapsed inward, leaving behind a circular scar. Even stranger are the magnetic anomalies sometimes found at the centers of these craters. These aren't just subtle shifts, they're stark, measurable spikes in magnetism that defy easy explanation. Some speculate they may be remnants of ferrous meteorite cores buried beneath the surface. Others wonder if they're caused by iron-rich geological structures rising up from the mantle. And then there are the hollow signals. That's right. In several radar surveys, researchers reported strange returns from within certain crater-like zones, returns that suggest cavities, open spaces, hollow regions within the ice or rock. In one case, a radar scan revealed a circular depression with a reflective band beneath it shaped like a dome. The data hinted at a large air-filled cavity hundreds of meters tall beneath miles of ice. Naturally, the internet went wild. Speculation ran rampant. Was this evidence of a buried base, a secret Nazi installation perhaps, or something older, an Atlantean outpost lost to legend? It's easy to laugh at such theories. They sound like pulp science fiction. But in a continent so rarely visited, so poorly mapped, and so layered in mystery, every blank space invites a story. You walk now toward one of these radar-identified zones. There's nothing to see at the surface, just snow, hard and dry, swept smooth by 1,000 storms. But you've seen the data. You know that under your boots lies a depression wider than the city of Los Angeles. You press your palm to the ice as if you could somehow feel the shape beneath. There's a low vibration in your bones, maybe from the wind, maybe from your own pulse, or maybe from below. Theories continue to swirl. Some scientists suggest these formations could be ancient subglacial lakes that drained and collapsed, leaving behind perfectly circular pits. Others propose that they may be geothermal vents where rising magma softened and melted the ice above, creating a slow-motion implosion. But what if it's something we haven't thought of? What if Antarctica's crust contains formations not seen anywhere else on Earth? Features sculpted during a primordial era before the continent split, when Antarctica was part of the lush supercontinent Gondwana. It's a strange thought, that this frozen wasteland was once green, warm, tropical, that these craters may not have been formed by ice or fire or rock, but by something alive, something big, something now gone. After all, some of Earth's oldest fossils were found not in the tropics, but in ice cores, in microbial mats trapped in permafrost, in sedimentary layers buried far beneath frozen shelves. And then there's the most radical theory, that these craters are not of earthly origin at all, that they are the remnants of objects placed, not dropped from orbit, structures or installations from an ancient civilization, either ours or someone else's, buried intentionally, hidden beneath layers of time and ice. It sounds outrageous, but so did the idea of plate tectonics once. So did the existence of microbial life in boiling sulfur springs. Science has always danced on the edge of imagination. You continue walking now in complete silence. The snow crunches beneath your feet. The stars above seem unusually clear. No satellites out here, no planes, just the cold and the sky. And under it all, a great circle of mystery. You wonder if one day someone will dig all the way down, break through the ice, lower a camera or a drone into the hollow, see what sleeps in the stillness. Maybe it's nothing, just ice and rock. But maybe not. Maybe something rests there, or waits. And as you turn back toward camp, one last thought brushes your mind, uninvited but persistent. What if these craters are entrances, not to caverns or bases, but to a story we've never been told? The wind returns not with fury, but with a kind of whispering insistence, like it's trying to speak. It slides across the open ice in sheets of fine powder, stirring phantom waves across the surface. You pull your collar up higher and continue forward toward a site that geologists have studied with increasing urgency, and environmental scientists approach with a kind of solemn awe. Ahead lies one of the most haunting changes ever recorded in Antarctica, the collapse of the Larsen ice shelf. You don't see it at first. It doesn't look like a disaster. There's no smoke, no rubble, no immediate signs of devastation. But then, as your boots crunch forward and your eyes trace the frozen horizon, you notice something wrong. A chasm where there shouldn't be one. A jagged, unnatural border stretching farther than your eyes can follow. A silence that feels recent. Larsen. A Larsen. B. Larsen. C. These aren't code names or expedition designations. They're vast shelf-like glaciers that once extended far into the Weddell Sea, acting like frozen arms reaching from the land into the ocean. Ice shelves like these are crucial for the continent. They act as brakes, holding back the inland glaciers behind them and preventing a rush of ice into the sea. But Larsen A disintegrated in 1995. Larsen B collapsed suddenly in 2002 in just over a month. And Larsen C, the largest of them, calved an iceberg the size of Delaware in 2017. Satellite imagery captured it all in excruciating detail, a 120-mile-long crack that slowly crept across the shelf for years before the inevitable happened. 1 trillion tons of ice broke free and drifted silently into the Southern Ocean. What's even more unnerving, there was no cataclysm, no earthquake, no volcano. The ice simply gave up. Historians still argue whether the collapse was entirely natural or if it's a dire sign of anthropogenic climate change. But most agree that warming air temperatures and rising ocean heat contributed to the internal weakening of the shelves. What scientists found after the break was even more chilling. When researchers arrived at the site of the Larsen B collapse, they expected to see jagged shards of ice. Instead, they found a glassy, calm bay where ice had once stood for more than 10,000 years. It was as if a wall had been lifted and the sea exhaled. Underneath the vanished ice, they discovered ancient sediments, rare bacteria, and deep fissures carved by rivers that hadn't flowed in millennia. It was like stepping into a room no one had opened in 100 centuries. And that's when it hit them this wasn't just about ice. It was about what the ice had been holding back. You stand now on the edge of a glacial shelf still intact, but perhaps not for long. The ice creaks faintly beneath your feet, not enough to frighten you, just enough to remind you that even something this massive, this ancient, can be fragile. Researchers monitoring the region with satellite interferometry noticed a pattern when one shelf collapses. The glaciers behind it begin to accelerate. Larsen B's breakup led to nearby tributary glaciers flowing 8 times faster than before. It's like snapping the tip off a frozen toothpaste tube and watching the contents squeeze forward, except this toothpaste is ice, and it holds seas level rise inside it. Imagine Antarctica contains over 26 million gigatons of ice. If even a fraction of its coastal shelves were to collapse like Larsen B, it would unleash an inland acceleration of ice into the ocean, raising global sea levels by multiple meters. You look up at the sky. It's absurd how peaceful it seems, but underfoot change is moving, slowly, relentlessly, and this is what makes Antarctica terrifying, not its storms or its temperatures, but its silence, its capacity to change dramatically without fanfare, without drama, just change. There's an eerie phenomenon here that scientists call hydrofracturing. Warm meltwater formed from increasing air temperatures collects in surface pools during the summer. That water seeps into small cracks in the ice, and as it descends, it forces those cracks open wider, using its own weight to split the ice from within. This process, simple water exploiting a weakness, was directly linked to the catastrophic disintegration of Larsen B. Water doesn't just melt ice, it breaks it. You think of that every time you see a melt pond shimmering in the distance. They're beautiful from afar, but they're a warning. And then there's the ocean's role. Beneath the ice shelves, warm ocean currents sneak in and erode the ice from below. It's invisible, undetectable without submersible sensors, but it's real. In fact, satellite readings now show that some Antarctic shelves are thinning by several meters a year at their bases. They're being undercut, hollowed out from the bottom like a termite-riddled beam. No loud cracking, no dramatic shift, just a slow surrender. And what happens when those shelves collapse? The ice above sea level doesn't cause sea level rise that's already floating. But when the shelves give way, they remove the buttresses holding back vast inland ice sheets, like removing a dam. Suddenly, thousands of gigatons of land-based ice are free to slide toward the ocean. Antarctica is changing faster than we thought. In 2022, satellite data revealed that some glaciers in West Antarctica had begun to retreat irreversibly their grounding lines, the places where ice meets bedrock, pulling back miles in less than a decade. The region is unstable, and it's vast. You sit now on the cold ground, staring out at a landscape that seems eternal, but it's not. Nothing here is permanent, and if the Larsen shelves are a preview, then the main feature is yet to come. The Thwaites Glacier, ominously nicknamed the Doomsday Glacier, is now considered the most vulnerable mass of ice in Antarctica. It's held in place by an ice shelf even more fragile than Larsen B, and if that shelf collapses, it could unleash a chain reaction. Not overnight, but over decades. Enough to raise sea levels by 2 feet. And if surrounding ice is destabilized, the number grows. That's why scientists race here each summer with sensors, drones, seismic tools, and ice-penetrating radar. They're trying to measure the unraveling in real time, to listen for fractures, to detect the final groans before collapse. Because unlike other mysteries in Antarctica, this one isn't theoretical. It's not speculative. It's not ancient or lost in time. It's happening now, and its consequences will be felt everywhere. As you stand again and begin the walk back toward camp, your boots crunch softly against the ice, and you find yourself glancing back at the horizon. You can't see the collapse. You can't hear it, but you can feel it in your gut. The world is shifting, and Antarctica is whispering the future beneath your feet. You walk further inland now, where the landscape looks even more abandoned by life, if that's possible. Gone are the occasional sightings of bird seals or distant expedition markers. Here, there is only ice. layer upon layer of it so dense and untouched that it feels more like the crust of another planet than a place on Earth. But just when it seems you've reached the limits of life itself, the continent surprises you once again. Because buried under this lifeless expanse, researchers made a discovery so eerie, so out of place, that it seems like the punchline to a bad explorer's joke. They found mummified seals far inland. You heard that right. Not fossils, not bones. Mummified, perfectly preserved leathery corpses of seals, sometimes dozens of them found miles from the coast, far from any sea ice, stranded in terrain that no living seal should ever have been able to reach. The first of these bizarre discoveries was made in the McMurdo Dry Valleys, one of the most desolate parts of the continent. Researchers stumbled upon the bodies while mapping wind patterns and glacial erosion. At first, they thought the seal remains were recent, maybe dragged inland by wind or scavengers. But radiocarbon dating told a different story. Some of these seals have been lying here for hundreds, even thousands of years. Frozen in the dry, hyper-arid air of the valleys, their bodies never decomposed. No bacteria, no fungi, just shriveled flesh and bones beneath a thin dusting of snow. Now seals are known for being curious creatures. They've been seen venturing inland on occasion, following cracks in the sea ice, or slipping through crevasses. But not this far, not this frequently. Because we're not talking about a single accident. Over 300 seal mummies have been discovered so far. What were they doing here? Historians still argue whether the animals were chasing smells, fleeing predators, or simply getting lost in blizzards. But these explanations don't fully satisfy. For one, the terrain in the dry valleys is brutal. It's not an easy hike for any creature, much less a marine mammal. There's no food, no water, no shelter, just a slow, painful death by exposure. So why do it, and why do it repeatedly? Some scientists propose that a combination of magnetic anomalies and topographical illusions might confuse the seal's navigation. Seals rely on the Earth's magnetic field and celestial cues to travel. Could gravitational irregularities in Antarctica disorient their internal compasses, drawing them far from the coast? It's possible. There's another theory, a more somber one, that ancient climatic conditions were once different enough to make these inland zones accessible or hospitable. Perhaps seasonal melt rivers once carved paths deep into the valleys, offering resting pools or small feeding grounds. In other words, maybe the terrain wasn't always so deadly. But that raises another question: how much of Antarctica's recent history have we completely missed? If seals once swam or crawled into now inhospitable areas, it implies rapid environmental shifts. The kind of change that outpaces evolution. The kind that strands animals in places they never meant to go. You crouch beside one of these mummified seals, now your breath frosting the collar of your hood. Its skin is leathery, pulled tight over brittle ribs. The eyes are long gone, but the expression, or what remains of it, is oddly serene. Was it confused, terrified, or just exhausted? There's something intimate about the scene. A quiet death in the middle of nowhere. No predators, no violence, just time. And time here is merciless. The dry valleys are the driest place on Earth. Some regions haven't seen precipitation in over 2 million years. Wind scours everything. Temperatures hover far below freezing year-round. There are no microbes in the soil, which is why the seals haven't rotted. They've desiccated. And here's where it gets stranger. Not all the mummies are in the same state. Some are twisted, collapsed, their bodies contorted as if they'd suffered before death. Others lie almost peacefully, their flippers tucked close, as if curled in sleep. Some show signs of internal bleeding, perhaps from pressure changes or altitude sickness. Others have strange lesions that scientists can't yet explain. And while it's tempting to wave it away as a bizarre footnote in nature's ledger, there's an undercurrent of mystery here that refuses to go away. Because these mummies aren't just a fluke, they're a pattern. And patterns beg for meaning. Some researchers have even proposed that these seals might offer valuable insights into long-term tissue preservation. That their mummified organs, untouched by decay, could help science learn how to better freeze and store human tissue, or even revive long-lost samples for study. Imagine that. The tragic, unexplained death of a seal in the middle of nowhere, becoming the key to some future medical breakthrough. There's something poetic in that. But there's another layer, a more haunting one. What if this isn't just about seals? What if there's simply the evidence that remains? What else may have wandered into the dry valleys? What else may have died in silence and left no trace? Antarctica is a vault after all. It doesn't give up its secrets easily. Bodies can lie preserved for millennia here, intact, sealed in cold, dry tombs of dust and ice. You scan the landscape now, half expecting to see something more. A hint of movement, a shadow against the rocks. But there's nothing. Just wind-carved ridges and long-forgotten seal corpses dotting the landscape like morbid waypoints. And then it hits you. What if we're next? Not in the apocalyptic sense, but in the archaeological one. What if someday explorers, human or otherwise, walk these valleys and find our remains? Our outposts, our machines, our myths. Would they understand the seal mummies? Would they understand us? It's the kind of thought that keeps you quiet long after the sun dips below the horizon. Because Antarctica doesn't just hide the past, it hints at the future too. And here, amid the wind and the ice and the bones of the curious dead, you feel like you're looking through time. A reminder, perhaps, that sometimes life doesn't end with a bang. It ends with a slow, frozen question mark. There's something surreal about silence this deep. It's not the kind you hear in a library or a remote forest. This is the kind that presses in from every direction, the kind that feels engineered. You walk through the crunching ice underfoot, but even your own footsteps seem to vanish into the stillness swallowed whole by the cold air. But silence doesn't mean lifelessness. Not here. Because beneath your boots, in a land once thought too barren to support anything at all, scientists have discovered organisms that might as well be science fiction, come to life, creatures that thrive, not despite radiation, but because of it. Welcome to one of the weirdest chapters in Antarctica's living library, the discovery of fungi that feed on radiation. It sounds like a discarded comic book plot. Fungi absorbing radiation like plants absorb sunlight. But it's real. And it was first discovered not in Antarctica, but in another place of silent ruin, the crumbling remains of the Chernobyl nuclear disaster. There, in the dark corners of reactor buildings, scientists noticed black mold, growing, not dying, in areas with high radiation. The organism in question, Cryptococcus neoformans, a type of melanized fungus. It was thriving in conditions that should have sterilized life. And the secret melanin, that same pigment that colors human skin, bird feathers, and squid ink. In these fungi, melanin plays a different role. It doesn't just absorb radiation, it converts it. The theory is that the fungi use melanin to transform gamma rays into chemical energy, effectively using radiation the way plants use sunlight in photosynthesis. This process, dubbed radiosynthesis, is still not fully understood. But the implications are massive. And then came the Antarctic connection. Researchers turned their attention to Antarctica's high radiation environments, not nuclear fallout zones, but areas like the McMurdo Dry Valleys, where the ozone layer is dangerously thin and UV radiation is intense. These are the highest naturally occurring radiation levels on Earth due to high elevation dry air and reflective snow. If anywhere mimics the radiation-bombarded surface of Mars, it's here. And sure enough, in samples taken from rocks and soils in these high-exposure areas, scientists found melanin-rich fungi. They weren't just surviving, they were thriving. Some species were even found living inside Antarctic rocks, a behavior known as endolithic colonization. They slip into microscopic crevices in granite or sandstone, forming communities just below the surface, safe from harsh winds, but still soaking up the available radiation. This is where things get really strange. When researchers exposed these Antarctic fungi to high doses of radiation in the lab, the fungi grew faster. Radiation, instead of being a hazard, became an energy source. Historians still argue whether these fungi are ancient holdovers from some primordial radiation-rich Earth, or whether they evolved this ability relatively recently. Either way, they are changing the way we understand biology. Because suddenly, the idea of life in the most extreme corners of the universe doesn't seem so far-fetched. Mars, Chernobyl, Europa. If fungi can learn to harvest gamma rays, who's to say life can't thrive in places we used to call sterile? You pause now at a shallow rock face where scientists have chipped samples from the inner walls. Under your gloved fingers, the stone feels cold, but faintly textured. You imagine what's happening just beneath the surface, a silent, slow metabolism of something most life forms flee from. These aren't your everyday mushrooms. They don't form caps or stalks. They don't sprout in forests. They don't spread spores you'd see with the naked eye. They're cryptic, microscopic architects of survival, and they may hold answers to questions we haven't yet asked. For example, could these fungi be used in radiation shielding? Some researchers are already experimenting with incorporating melanin-rich fungal mats into materials for spacecraft walls. The goal: passive radiation protection for deep space missions. A biological barrier against cosmic rays. Imagine astronauts traveling to Mars wrapped in a living cocoon of melanin-rich fungus, engineered not just to protect them, but to grow stronger under exposure. Antarctica once again becomes a model for Mars. And there's another thought that creeps in as you stare at the rock. What if these fungi aren't just adapting to radiation? What if they require it? What if their entire energy metabolism is tuned to something that to us is poison? That flips the script, doesn't it? Radiation is supposed to kill. But here in Antarctica, it's the catalyst for life, for a different kind of photosynthesis, for a different kind of world. You think about Earth post-human, long after we vanished, ice reclaiming cities, oceans rising and falling again, radiation from the sun seeping into the crust, and somewhere in the forgotten corners of the planet, these fungi continue, feeding, spreading, outlasting, not the dominant life form, just the final one. And it makes you wonder, are they a preview of what life becomes in the long dark? Could life begin with sunlight and end with gamma rays? The idea isn't as far-fetched as it sounds. After all, life on Earth may have begun in deep-sea vents, far from the sun, fueled by geothermal radiation and chemical gradients. Maybe radiation is just another kind of energy source in nature's toolkit. You take one last look at the rock face, then mark your sample container and begin the walk back. But the idea lingers. That life doesn't need to be beautiful to be remarkable. That survival isn't always loud or heroic. Sometimes it's slow, patient, invisible, feeding on the very thing that should have killed it. And in the case of Antarctica's radiation-eating fungi, that's not science fiction. That's a quiet fact buried in ice. As you trek deeper into the frost-bitten belly of the continent, you start to notice that the rules of biology as you know them begin to twist a little. Life here doesn't follow the textbook. It bends, it mutates, it rewrites itself in code that's far more alien than familiar. And in this next chapter, you meet a creature that shouldn't exist, at least not by any normal standard. Welcome to the world of the icefish that survives without hemoglobin. Now let's pause for a moment. You've probably heard the word hemoglobin tossed around in high school biology or on a hospital show. It's the molecule in red blood cells that carries oxygen. Without it, your blood wouldn't be red, and your organs wouldn't get the oxygen they need. But in the freezing, oxygen-rich waters around Antarctica, scientists discovered a fish that simply doesn't bother with it. It doesn't have red blood. Its blood is clear, and yet it's alive. It swims, it breathes, it thrives in some of the coldest waters on Earth. Say hello to the Channictidae, or more simply, the icefish. When biologists first dissected these creatures, they were baffled. No red blood cells, no hemoglobin. It was like opening a car hood and discovering the engine's missing, but somehow the vehicle still runs. At first, many assumed it had to be a mistake, a lab error. But no. These fish had evolved in this peculiar direction intentionally. But how do they do it? The answer lies in extreme specialization. Antarctic waters are not only cold, they're also supersaturated with oxygen. Cold water holds more dissolved oxygen than warm water. That means these fish can survive by simply dissolving oxygen directly into their blood plasma, rather than relying on red blood cells to carry it. To compensate, ice fish have enormously large hearts up to 4 times the size of other fish, their size, wider capillaries and slower metabolisms, blood that circulates at a higher volume, almost like a flood of antifreeze. It's a biological workaround so improbable, so elegant, that even evolutionary biologists had to sit down and admire the sheer audacity of it. And that's not all. Some species of icefish also produce antifreeze proteins in their blood, preventing their tissues from freezing solid in sub-zero water. These proteins bind to ice crystals as soon as they begin to form, halting their growth. Think of it like molecular-level sabotage. Ice can start, but it can't finish. Now you might be thinking, why give up hemoglobin in the first place? Isn't it, useful? Yes, normally. But researchers believe the ancestors of icefish once had hemoglobin just like all other vertebrates. Then, around 5 to 10 million years ago, something shifted. A genetic mutation likely disabled hemoglobin production. In most animals, that would be fatal. But in the cold, rich waters of the Southern Ocean, it wasn't. Historians still argue whether this mutation gave the icefish an actual advantage, perhaps by lowering the energy cost of maintaining red blood cells, or whether it was a neutral accident in an environment forgiving enough to let it stick. Either way, evolution said, sure, let's try no hemoglobin and see what happens. And it worked. You glance down now into a hole cut into the ice shelf, a perfectly round window into the inky ocean below. A research station nearby lowers a submersible camera, its lights piercing the darkness. And then you see them. Pale, almost ghostly, the icefish glide through the water like phantoms. There's no flash of red, no shimmer of scales, just translucent bodies drifting through a realm that seems to belong to a different Earth. You wonder if they see the light, if they feel it, if they register the presence of your machine as alien an intrusion, or merely another current moving past them. There's something humbling about watching a creature that defies everything you thought life required. These fish didn't lose hemoglobin as a weakness. They shed it like an unneeded coat. In the Antarctic's unique evolutionary theater, they rewrote the definition of viable biology, and now their genetic adaptations are helping us. Scientists studying icefish are trying to understand their antifreeze proteins at a molecular level, hoping to use similar mechanisms to preserve human organs for transplant. The antifreeze genes are also being investigated for use in crops to help protect them from frost. Even aerospace industries are studying the structure for anti-icing materials. Who knew a see-through fish could help keep your lettuce safe from freezer burn? And here's another curveball. Icefish might be helping us understand climate change too. Because their biology is so tightly bound to cold, they're like natural thermometers. Even small rises in water temperature begin to affect their ability to metabolize oxygen. As the Southern Ocean warms even by a degree or two, icefish populations are showing signs of stress. Their hearts, so large and efficient, are beating too fast. Their blood, so perfectly designed for icy waters, is struggling to cope. They are quite literally outgrowing their niche, and that means researchers are watching them like sentinels. If icefish populations decline, it may signal that we've crossed an invisible line, a shift in the Southern Ocean that could ripple across the global ecosystem. And you stand here, the cold creeping up your legs despite the thermal layers, and realize how strange this all is. That the fate of the oceans might lie in the hearts of creatures with clear blood. That evolution, so often framed as a race to adapt, sometimes rewinds and removes. That life is never finished designing itself. And in a world teetering between change and collapse, Maybe the ice fish has something to teach us, not just about biology, but about resilience, about quiet, transparent persistence in the face of cold odds. The camera rises now, dripping and blinking as the team recovers it. You step back from the ice hole, one last glance at the darkness below, and imagine those ghostly shapes still drifting, still alive, still doing what they do best. Defying expectations, you make your way across a ridge of ice sculpted by wind and time, and for a moment, the world feels as though it's holding its breath. No howling gusts, no shifting snow. Just you alone with the sky, standing above one of Antarctica's quietest enigmas, one that doesn't take the form of strange creatures or ancient ruins, but rather something you can't quite explain away. You're about to learn about electromagnetic signals, unusual, unexplained, and persistent, that seem to pulse from deep within the ice. This isn't conspiracy theory territory. These signals aren't claimed by ufologists or whispered about in Reddit threads. They've been measured, recorded, and studied, and still no one's entirely sure what they mean. It began with a series of anomalies detected during research into Earth's magnetic field. As scientists deployed magnetometers and radio wave detectors across the Antarctic plateau, they began noticing oddities, spikes in low-frequency electromagnetic activity that didn't match any known pattern of solar interference, tectonic activity, or man-made source. They were faint, rhythmic, and coming from beneath the ice. To be clear, the Earth constantly emits a variety of natural electromagnetic waves. The planet's molten core generates a protective magnetosphere. Lightning strikes create pulses called spherics. Even auroras produce low-frequency hums as charged particles rain from the sun. But this was different. These Antarctic signals had no obvious external trigger. They appeared most strongly in areas where the ice sheet was thickest, places like the East Antarctic Plateau and Wilkes Land, far from any research station or electronic interference. Some researchers initially assumed these were just ice quakes, the frozen equivalent of a tectonic jolt. Ice can crack and shift under pressure, generating low-frequency rumbles. But ice quakes are usually short and chaotic. These were structured, repeating. Even stranger, they often coincided with anomalies picked up on ground-penetrating radar and gravitational sensors, suggesting the electromagnetic patterns might be tied to something deep and massive. A buried structure, a natural geologic feature, or something else entirely. Historians still argue whether these signals could be linked to subglacial lakes, metal-rich geological formations, or even trapped magma chambers. After all, Antarctica has a volcanic underbelly. There are known hotspots beneath the ice, some still active, their heat slowly melting channels deep underground. But the electromagnetic signals don't correlate cleanly with known volcanic zones. They don't pulse like magma, and they don't act like the echo of flowing water. Instead, they resemble very low-frequency VLF transmissions, similar to the kind submarines use to communicate beneath the ocean. A steady, rhythmic signal that hums at the edge of perception. When isolated on a spectrogram, it looks almost artificial, like code. But from who? From what? This is where the story gets weird. In 2016, a joint research group from the US and Germany published an observation of what they called persistent subglacial VLF activity in Queen Maud Land. The data showed a continuous narrowband frequency being emitted, not detected passively, but emitted from a fixed location beneath several kilometers of ice. No known human technology could have reached it. There were no active instruments, no transmissions scheduled. And yet, there it was, pulsing, waiting. So naturally, the speculations began. Some called it a buried natural battery, a mineral-rich geologic formation acting like an underground capacitor, charging and discharging energy over long periods. Others proposed it might be the result of piezoelectric activity, where pressure on quartz or other crystals produces voltage. That's not science fiction. It's been observed in mountain ranges and seismic zones. But Antarctica is different. It's quieter. It hides things better. And then, of course, came the fringe theories. that the signals are evidence of a buried alien artifact still transmitting, that they're relics of a forgotten civilization using technology now lost to us, that Antarctica's ice isn't just preserving the past, it's censoring it. And while those ideas are fun to entertain, scientists remain cautious. Most lean toward a natural but still unknown origin. One researcher described the signals as a language we haven't yet translated. It's a poetic way of saying we're listening, but we don't know what we're hearing. You pause now at a monitoring station set up to record these electromagnetic fluctuations. A small array of antennas juts from the ice like metal thorns. The instruments are silent, their data silently feeding into cloud servers, pinging satellites overhead. A world away, researchers in Germany, Japan, and Colorado sift through the noise looking for patterns. And they're finding some. Certain emissions seem to follow lunar cycles, suggesting a gravitational link. Others spike during aurora events, hinting at interaction with the magnetosphere. But the core mystery remains. Why are these emissions so localized? Why do they seem to come from within, rather than pass over or through the continent? One tantalizing clue lies in the Wilkes Land crater, a massive depression buried beneath the East Antarctic ice sheet. Some have proposed that this ancient impact site, possibly from an asteroid over 300 kilometers wide, could be the source of residual magnetism seeping through the crust like ghostly static. If true, then the Earth itself is remembering a trauma millions of years old, and it's speaking in radio. But there's another possibility. What if something beneath the ice is generating these signals on purpose? We've found microbial mats that conduct electricity. We've found ice that generates voltage under pressure. We've found lakes under the ice with temperatures above freezing and unknown chemical compositions. Could life, unlike any we know, be communicating not with sound or light, but with electromagnetic pulses? Could these signals be a biosignature? It's not likely, but it's not impossible. And in Antarctica, that's enough. Because this isn't a continent of certainties. It's a continent of questions. And this one, this quiet, pulsing mystery under the ice, might be its strangest whisper yet. As you look back at the antennas one last time, a light on the console flashes. A new signal, a new pulse. No thunderclap, no explosion, just a blip in the data. A slow, patient drumbeat from a world we don't yet understand. You smile a little, your breath frosting in the still air. Because Antarctica isn't silent after all. It's speaking. We just haven't learned to listen properly. It begins as a whisper beneath your boots, a kind of stillness that feels oddly expectant. You're walking over what appears to be an unbroken plain of glacial ice, rippled by centuries of wind, but undisturbed by any recent footprint. And yet, beneath all that ancient silence, something is happening. Something impossible. Because down there, where no sunlight has touched in millions of years, lie lakes. Liquid lakes, and they don't freeze. Let that sink in for a moment. This is the coldest place on Earth. Temperatures regularly drop below 90 degrees Fahrenheit. And yet, here entombed beneath miles of solid ice are entire bodies of water that refuse to solidify. They flow, they pulse, they shift beneath the pressure like hidden heartbeats. Tonight we delve into the surreal world of bizarre under-ice lakes that don't freeze. Let's start with the best-known Lake Vostok. Discovered beneath Russia's Vostok Station in the 1990s, this subglacial lake is one of the largest in the world, over 160 miles long, 30 miles wide, and buried under 2.5 miles of solid ice. That's the height of 40 Eiffel Towers stacked end to end. No light, no air, no obvious energy source. And yet, it's liquid. How? There are a few mechanisms at work here. The most obvious is geothermal heat. The Earth's core radiates a small but steady trickle of warmth upward, which over millions of years can be enough to slightly melt the deepest layers of ice. But the bigger player pressure, ice like any solid has a melting point, and when you stack miles of weight on top of it, the rules change. That crushing pressure lowers the melting point, allowing water to remain liquid even in temperatures well below freezing. Combine that with a little geothermal nudge, and voila, liquid lakes sealed beneath an icy tomb. So far, scientists have identified over 400 of these lakes across the continent. Some are small pockets, others are vast systems that flow between valleys and ridges. Some sit still. Others seem to drain and refill, connected by subglacial rivers we can't yet fully map. But what's in them? That's the real mystery. Because these lakes are completely cut off from the outside world. No sunlight, no surface nutrients, no atmospheric contact. And yet some researchers believe they could harbor entire ecosystems adapted to darkness pressure and chemical energy. In 2012, Russian scientists finally managed to drill into Lake Vostok without contaminating the pristine water below. The core samples they pulled up hinted at microscopic life bacteria that were unlike any known species and capable of metabolizing in extreme conditions. Historians still argue whether those life forms were native or introduced via the drilling process, but the tantalizing idea remains. That alien biology may not be found on Mars or Europa, but right here under our feet. And Vostok is just the beginning. Other lakes like Lake Whillans and Lake Mercer have also been drilled and sampled more recently using sterile techniques and hot water drilling to avoid contamination. These efforts have revealed signs of viable microbial life, organic compounds, and even suspended sediments suggesting an ancient connection to the ocean. Imagine that buried lakes containing trapped ocean water, possibly dating back millions of years, when Antarctica was lush and green. That's not just fascinating. That's a time capsule. It's not hard to imagine what else might be locked away down there. Fossilized plants, ancient viruses, genetic blueprints from a prehistoric Earth, or if you want to go full speculative, the remnants of something intelligent. Let's pause for a second. It's not so outlandish. Think about it. If you were trying to hide something, would you bury it in the desert? Or would you sink it beneath 3 miles of ice in a place no one visits, in an environment too hostile to explore? Some theorists, even a few geophysicists, have wondered aloud, could certain subglacial formations be more than natural? The smooth dome-like curves seen in some radar scans, the hollow zones, the inexplicably uniform lake beds. It could be coincidence, or it could be architecture. And even if it's just natural geology, the physics alone are mind-bending. Some of these under-ice lakes have tidal patterns. You heard that right. Even though they're completely buried, the moon still affects them. Its gravitational pull causes the ice sheets to flex ever so slightly, which causes water in the lakes to rise and fall in rhythm. A kind of invisible tide humming under the continent in darkness. You imagine standing above one now, listening closely, feeling that subtle glacial pulse beneath you. It's not loud, it's not dramatic, but it's there, and it's alive. And if that weren't strange enough, consider this. Some of these lakes are warmer than the surrounding ice, not just a few degrees, but by margins large enough to suggest an internal heat source, possibly chemical reactions in the sediments, possibly geothermal vents, possibly something we haven't named yet. These are Earth's own black boxes, sealed environments untouched by surface evolution, where life may have followed a completely different path. A parallel biosphere, a different experiment. And there's one more twist. When lakes drain suddenly and massively, they send waves rippling through the ice above. These subglacial floods can move billions of gallons of water through underground channels in just days. The surface doesn't crack or collapse, but satellites have tracked subtle dips and bulges rippling like a waterbed under pressure. You're standing on one of those now. Beneath you, a river may have carved its way from one lake to another, leaving behind a story no one ever saw. No sound, no splash, just gravity and melt and motion. So here's what you're left with: a continent full of invisible lakes, connected by underground rivers, pressurized by glaciers, heating from below, pulsing with ancient tides, and maybe, just maybe, holding life. It's like something out of a dream or a science fiction novel, but it's real. And as you walk away from the ridge, the idea stays with you that under the frozen silence, the Earth remembers something. A time before ice, a time before history, a time before humans. And somewhere in the dark, something still moves. The cold is constant, but now it carries with it a strange sense of expectation. You've crossed ancient valleys, walked above hidden lakes, stood silent before ice that hums and pulses. But tonight, you're approaching something far more volatile. This next phenomenon isn't just a curiosity. It's a threat, a sealed, pressurized, ticking time bomb. Tonight, we sink into the mystery of trapped methane reservoirs, pockets of frozen gas lying dormant beneath the Antarctic permafrost, quietly waiting for the wrong conditions to set them free. Let's start with the basics. Methane is a powerful greenhouse gas over 25 times more potent than carbon dioxide at trapping heat in the atmosphere. Most of it on Earth is produced by biological processes decaying organic matter, swamp gas, digestive microbes. But vast amounts are also stored underground, particularly in the form of methane hydrates. Methane hydrates are like chemical ice cages, crystalline structures made of water that trap methane molecules inside. They're stable only under two conditions: cold temperatures and high pressure. If either of those changes, the cage breaks down and the methane is released. Antarctica, unsurprisingly, provides the perfect conditions to form these hydrates. Beneath its thick ice sheets, especially along the coastline and continental shelf, lies a layer of permafrost, permanently frozen sediment, and organic material. Trapped in this frozen underworld are massive stores of methane, some of it from ancient plant life dating back millions of years. Now, for a long time, no one thought much about it. The ice was thick. The temperatures were stable. The gas stayed locked away. But then came the warming. Over the last few decades, Antarctica's western shelf has been warming faster than almost any other place on Earth. Surface ice is melting. Subsurface temperatures are creeping upward. And the deeper the warmth seeps, the more unstable these methane stores become. And when they release, well, let's just say, things get complicated. Scientists have begun detecting methane plumes, columns of gas bubbling up from the ocean floor around Antarctica, especially in regions like the Ross Sea and Amundsen Sea embayment. Some are minor, small enough to go unnoticed except by sensors. Others are massive, stretching dozens of feet across and reaching all the way to the surface. And that's just what we found. There could be thousands of similar plumes elsewhere beneath ice, beneath sediment, simply waiting to activate. Historians still argue whether these methane reserves are a recent formation or ancient relics from when Antarctica was lush and forested. Either way, their presence poses a significant climate wildcard. Because when methane is released, it accelerates warming. And when warming accelerates, more methane is released. It's a feedback loop, a runaway engine, and one we may already be igniting. One especially chilling study came from the East Antarctic margin, where geologists drilled into the seabed and found large deposits of methane hydrate less than 100 meters below the seafloor. Even a slight temperature rise in bottom water, just 1–2 degrees Celsius, could destabilize those deposits. Now remember, methane doesn't just drift upward and vanish. If released in shallow waters or on land, it can vent directly into the atmosphere. And since Antarctica lacks the dense vegetation or microbial mats that would typically absorb such emissions, the gas may go unfiltered straight into the sky. This is where science gets nervous, because models of future warming often struggle to account for abrupt nonlinear releases, things like permafrost collapse or hydrate destabilization. We're talking about bursts of methane, not gentle leaks. Sudden surges that could tilt climate systems further off balance. And yet, that's not even the weirdest part. In 2020, researchers studying the Larsen ice shelf discovered something unsettling. Deep beneath the ice, in a zone that had recently collapsed, they found signs of ancient microbial activity bacteria that had survived perhaps for centuries or millennia by feeding on methane. Yes, you heard that right. Life that eats gas. These microbes live in a dark, cold, anoxic world. No light, no oxygen, no plants, and yet they thrive. They consume methane and convert it into energy. It's a process known as methanotrophy, and it's not just fascinating, it's crucial, because these microbes may be the only thing holding the line. If widespread methane release begins, they could act as a biological brake, consuming some portion of the gas before it escapes. But their reach is limited. If the release is too fast, too large, or too widespread, they'll be overwhelmed, and we'll be left with an atmosphere growing warmer by the hour. So how do we monitor all this? That's the tricky part. You can't just walk out with a methane sniffer and poke holes in the ice. These reservoirs are deep fragmented and often located in unmappable terrain. Scientists use a combination of seismic imaging to detect hydrate layers, under-ice sonar to locate plumes, satellite altimetry to observe surface deformation, and chemical sensors mounted on autonomous underwater vehicles. But it's like watching a pressure cooker from the outside. You can listen for whistles, you can feel for heat, but unless it explodes, you don't know how close it was. As you stand now on the Ross ice shelf, the wind hissing past your hood, you try to imagine what's directly beneath you. A gas pocket the size of Manhattan, a silent lake of hydrate, a microbial colony pulsing with slow ancient metabolism. Whatever it is, it's waiting. It might wait another 1,000 years, or it might not. One of the most unnerving scenarios involves the sudden collapse of a key glacial outlet like Thwaites Glacier, also known as the Doomsday Glacier. If it goes, it could not only raise sea levels by over 3 feet, but also destabilize massive hydrate fields beneath its floating tongue. A geological tripwire, a frozen detonator. And you realize then, with a quiet sense of awe, that Antarctica isn't a relic of the past. It's a gatekeeper of the future. Its silence isn't just ancient, it's loaded. So as you turn away from the frozen bay, casting one last look at the blue cracks snaking across the ice shelf, you carry a new kind of respect. For things that are silent, for things that wait, for pressure you can't see. Because sometimes what lies beneath the surface isn't just a mystery. It's a warning. The air grows impossibly still. Even the wind, your ever-present companion across the Antarctic wastes, seems to pause. You've seen silent valleys, glowing caverns, frozen creatures, and ancient maps, but what lies ahead now is something truly haunting. Not alive, not moving, not mysterious in the traditional sense, but still utterly unsettling. Tonight, you approach the 500-million-year-old organisms found in Antarctic ice cores. Let that sink in. 500 million years. This isn't about bones or footprints or fossils. It's about living things, or what remains of them, tiny ancient organisms whose last breath was drawn before the continents looked anything like they do now. When life was still testing out eyes and shells, when predators hadn't quite figured out how to hunt, before trees, before dinosaurs, before almost everything. And somehow traces of that life are still locked inside the Antarctic ice. Let's start with how we even got to this point. Ice core drilling is like archaeology, but colder. Much colder. Scientists bore down into Antarctica's ice sheets, using enormous drills extracting long cylinders of ancient ice, some of them miles deep. These cores are layered chronologies, each inch representing a season, a snowfall, a year. And the deeper you go, the older it gets. In 2010, a research expedition working near Dome C in East Antarctica pulled a segment of core from over 3.2 kilometers deep, a depth associated with ice around 800,000 years old. But embedded in that core were particles that under a microscope changed everything. Tiny fragmented structures that looked biological. Now, before we get carried away, most of these weren't alive, not in any sense we'd recognize. But their shapes, membranes, and chemical residues suggested they were once part of microorganisms, probably cyanobacteria, diatoms, or other primitive life forms. And based on isotope analysis and layering estimates, Some of these structures dated back as far as 500 million years. That's Cambrian period. That's explosion of life era. That's when life went from gooey blobs to things with claws and exoskeletons. And here, beneath 10,000 feet of ice, were its ghostly echoes. But how could something so old end up in the Antarctic ice sheet? There are two major theories. The first is wind transport. Dust storms and atmospheric currents can lift microscopic organisms and carry them across entire continents. Some believe that during massive extinction, events, or atmospheric upheaval, ancient organisms were swept up and deposited on what is now Antarctica, then trapped under snowfall, compressed, and forgotten. The second theory is even wilder. It suggests that Antarctica itself was once home to these organisms, that during the Cambrian period, the landmass that would become Antarctica was lush, shallow, and warm, teeming with microbial life. Over millions of years, as tectonic drift dragged the continent southward and the ice crept in, those ecosystems were frozen in place, preserved in ice as they died. Historians still argue whether these traces are direct evidence of native Antarctic life or just ancient passengers that hitched a ride. But in either case, they offer a window into Earth's deepest biological past. And some of them, they might still be viable. This is where the story gets eerie. In a few cases, scientists have warmed up ancient ice samples, not to room temperature, but just enough to allow basic metabolic reactions and observed faint biochemical activity. Enzymes flickering back to life, membranes twitching. Not life exactly, but potential. A microbial Lazarus effect. In 2004, a team from Montana State University extracted live bacteria from an ice core estimated to be over 32,000 years old. In more recent studies, cells from cores dated at 120,000 years were revived and grown in lab conditions. And while nothing yet has come out of a 500 million-year-old sample, singing and dancing, the possibility that some form of stasis or dormancy might exist is tantalizing. Think about that. The DNA of an organism older than vertebrates still intact enough to twitch. It's like opening a message written in a language no one has spoken for 500 million years and finding that the ink is still wet. Now imagine the implications. These ancient genes could help us understand how life evolved resilience, how organisms survived asteroid impacts, global ice ages, massive carbon shifts. They could carry molecular blueprints for survival written during the Earth's hardest times. We're not just talking about history. We're talking about biotechnology. Pharmaceutical companies are already studying Antarctic extremophiles organisms that thrive in cold for enzymes that can function in frozen conditions. These might one day be used in medicine, food preservation, or even terraforming. And deep under the ice, untouched and unmutated, lie entire catalogs of pre-human DNA. But here's where things veer toward the surreal. Some researchers believe that ancient microbial life trapped in ice cores may bear resemblance to potential extraterrestrial organisms. Why? Because the conditions, darkness, cold, pressure, isolation, are strikingly similar to what we expect on moons like Europa or Enceladus. If life ever evolved on those worlds, it might look less like a green alien and more like a bacterium in an Antarctic snowflake. And if it did, we may already be studying its cousin. You kneel now beside an insulated case, its seal frosted over. Inside is a fragment of core no wider than your wrist, encased in sterile plastic. If you were to crack it open just for a second, you'd be releasing air last breathed in the time of trilobites. It's humbling, and maybe a little terrifying. Because as you've seen on this journey, Antarctica doesn't just preserve the past, it collects it, layers it, compresses it into cold memory. And somewhere down there, trapped between ice crystals, something from before the world began as we know it, still waits. A whisper, a gene, a life. Maybe not alive, but not quite dead either. And you take one step back, one slow breath, and feel a deepening respect for this strange continent. It's not just a place of silence. It's a vault, a museum, a mausoleum, And a warning. What else lies in that ice unread? What secrets slumber not because they're gone, but because no one's brave enough to wake them? And as you look across the endless white, that question lingers longer than the wind. You've made it this far. The wind has long since stopped howling, the light dimmed to a soft silver sheen that reflects off the endless ice. You've passed hidden lakes that never freeze, fossilized forests that defy the climate signals that speak in electrical pulses, and organisms older than history. But this last chapter, this final hush before sleep, brings you to a place where all those mysteries converge, not as data or artifacts, but as a feeling. A question. You're standing now on the polar plateau deep within East Antarctica. Beneath your boots, the ice is more than 3 miles thick. It's the coldest place on Earth. And under that crushing ancient blanket, scientists have recently uncovered something peculiar, an anomalous magnetic structure that doesn't quite fit anything we've seen before. Welcome to the enduring mystery of the Wilkes Land gravity anomaly, a gravitational distortion so massive and so hidden that it may be one of the last unexplained geophysical features on Earth. Let's set the stage. Back in 2006, NASA's GRACE satellites designed to measure Earth's gravitational field passed over East Antarctica. Their job was to track minute changes in gravity by measuring the distance between twin satellites as they orbited the planet. The more mass below, the more gravity. It's a clever system. But when the satellites passed over Wilkes Land, they detected something unexpected. A massive gravitational anomaly. A dip, like a bowl stretching 500 kilometers wide and several hundred meters deep. That's about the size of Ohio. It's buried beneath more than 2 miles of ice and doesn't line up with any known geologic feature. And here's the kicker, right in the center of this gravity dip is a magnetic anomaly, a disturbance in Earth's magnetic field, strong and circular, like the remnants of a colossal impact. Historians still argue whether this is the site of a massive asteroid collision, possibly even the one that triggered the Permian-Triassic extinction, a mass die-off that occurred about 250 million years ago, long before the dinosaurs met their fiery end. That event wiped out 96% of marine life and 70% of land species. It's known as the Great Dying, and it may have started right beneath your feet. Think about that. You're standing on the possible impact site of an object that changed the entire course of life on Earth, and no one even knew it was here until a satellite spotted a subtle gravitational hiccup from orbit. But that's just one theory. Others suggest this anomaly could be the remnant of a mantle plume, a rising column of hot rock from deep within the Earth, or a sunken piece of an ancient supercontinent, or something else entirely. Because here's where things get weird. Radar imaging of the anomaly shows what appear to be geometric structures beneath the ice, unnatural shapes, symmetry, lines that don't occur in nature, not easily anyway. Now we must be careful here. Geometric doesn't always mean artificial. Nature can surprise us. But these formations sparked a flurry of speculation. What if there's something down there? A buried city, a long-lost base, even a civilization swallowed by time and ice. It sounds like science fiction, and maybe it is. But remember, you've already seen glowing caves, ancient rainforests, sealed lakes, teeming with unseen life. Antarctica is no ordinary place. It hides things. And Wilkes Land, it may be the deepest secret of all. If it was an impact site, the heat released would have been beyond comprehension, enough to vaporize rock, alter the atmosphere, and send shockwaves around the globe. The ice wouldn't have stood a chance, and anything alive nearby obliterated. But perhaps, just perhaps, some record remains. Not written on paper, but in the patterns of rock and ice. And perhaps, in the magnetic fields themselves. Because one of the strangest aspects of this anomaly is how it seems to persist. Unlike most impact scars which fade over time, Wilkes Land's gravitational and magnetic fingerprints remain crisp, active even. Some researchers believe it could still be influencing the movement of ice above, subtly shaping the Antarctic landscape. Others aren't so sure. Some say the anomaly is nothing more than dense mantle material or an ancient sunken terrain. No mystery, no hidden chambers, but they can't explain the magnetic pulse. They can't explain the symmetry, and they can't explain why, despite repeated attempts, no one has been able to drill deep enough to confirm what's really down there. Maybe it's because it's just too remote, too expensive, too dangerous. Or maybe some things aren't meant to be unearthed. You stand now at the edge of a shallow ridge overlooking the theoretical center of the anomaly. Nothing marks the spot. No signposts, no flags. Just a hollow echo beneath the ice where instruments detect weight, but nothing visible fills the space. You lower your hand and touch the frozen ground. Beneath this very point, the earth might still be humming with memory of fire, of collision, of extinction, or of something more deliberate. Somewhere between myth and science, the mind begins to wander. You remember those ancient maps, like the Piri Reis map, which showed Antarctica ice-free centuries before it was officially discovered. You think about the rumors of lost Nazi expeditions, secret bases, and spacecraft buried in ice. You don't need to believe those things, but you start to understand why they persist. Antarctica invites it. It's the only place on Earth where vast regions remain unseen. Entire mountain ranges cloaked by ice, lakes that have never rippled in open air, signals that have no clear source, magnetic scars from ancient impact or from something else. So, as the cold creeps in and the stars blur above you, you start to feel it, not fear, but reverence. A quiet awe for a continent that has refused to give up its secrets. Antarctica isn't loud. It doesn't roar or burn or shout. It waits, and it remembers. Long after the winds settle and the snow smooths out your footprints, this place will go on, holding its mysteries close, preserving the echoes of things too strange to explain, too vast to forget. And you, having walked its surface, listened to its heartbeat, and touched the edge of its truth, will carry that silence with you. Into sleep, into tomorrow, into the soft dark where questions live. The journey is nearly over, but Antarctica still has one last trick, one final invisible phenomenon that stretches not just across ice and rock, but across time and space. It isn't something you can see or touch, but it's something that affects every compass on the planet. You're about to enter the realm of the magnetic South Pole, a place that refuses to stay still. Most people assume the South Pole is a fixed spot. Like the North Pole, it's marked on maps and used as a reference for navigation geography and even mythology. But there are two South Poles. The geographic South Pole is the one marked by coordinates 90 degrees latitude, where the Earth's axis of rotation pierces the surface. But the magnetic South Pole, that one moves, and it's moving fast. As of today, the magnetic South Pole is no longer located neatly within the central ice cap. It's migrating hundreds of miles over the past few decades toward the coast and even slowly drifting northward into the Southern Ocean. So what's going on here? Let's take a step back. Earth's magnetic field is generated by the churning of molten iron in its outer core. This creates a vast dynamic electromagnetic field that surrounds the planet, shielding us from solar radiation, guiding migratory animals, and keeping our navigation systems functioning. But this field isn't constant. It wobbles, it shifts, it has moods. The magnetic South Pole was first located by explorers in 1909, around the edge of the Antarctic Plateau. Since then, it's moved over 400 miles, and in recent decades the pace has accelerated dramatically. Whereas it used to drift a few miles per year, it's now migrating at 10 times that speed, and no one knows exactly why. Historians still argue whether this sudden acceleration is part of a natural cycle, a prelude to a magnetic pole reversal, or the symptom of deeper anomalies brewing under the Antarctic crust. Yes, pole reversal. The Earth's magnetic field has flipped before. In fact, it's happened many times in geologic history, on average every 200,000 to 300,000 years. North becomes south, and south becomes north. The last one occurred about 780,000 years ago during the Brunhes-Matuyama reversal. So, we might be overdue. And the magnetic anomalies under Antarctica, the Wilkes Land gravity dip, the Marie Byrd Land heat flux, even strange electromagnetic pulses recorded beneath the ice might not just be curious features. They might be signs. Changes in the core, cracks in the crust, thermal disturbances that we haven't yet mapped properly. Something down there is interfering with the field. We know this because satellite data shows concentrated magnetic flux anomalies across East and West Antarctica, like scars in the planet's electromagnetic fabric. They don't behave predictably. They shift, stretch, and sometimes disappear entirely. Even more strange, certain regions in Antarctica have experienced compass errors during expeditions, not just slight needle wobbles, but full reversals or dead zones where magnetic readings become useless. Some are chalked up to local iron deposits. Others remain unexplained. You might not notice this on foot, but for satellites and submarines, this kind of interference can be serious. Military and civilian navigation systems must now recalibrate regularly due to the magnetic pole's drift. Even Google Maps and airline autopilots need constant updates to avoid misalignment. And it's not just the South Pole. The North Magnetic Pole is also on the move, racing from Canada towards Siberia at an unprecedented pace. It's as if the entire magnetic field is wobbling, shifting like a bowl of soup, being stirred slowly but forcefully from below. You kneel in the snow, now holding an old-fashioned compass in your gloved hand. The needle spins, slows, then jerks northward, except it's no longer pointing the way it did yesterday, or the day before. The Earth, you realize, isn't quite the solid, steady ball we pretend it is. It's alive beneath us, not just geologically, electromagnetically. It hums, it pulses, it shields us from death and guides our technology, and yet we barely understand it. So here's a thought to take with you. If our magnetic field suddenly collapsed or reversed, we'd be exposed. Solar radiation would strip our satellites. Communications would fail. Navigation systems would collapse. Migratory birds would fly in circles. Whales might beach themselves in confusion. And us, we'd lose the invisible thread we've always relied on without ever truly knowing how it worked. Somewhere beneath Antarctica, that thread is fraying, or tightening, or changing into something we haven't seen in 780,000 years. And it starts here, in the quietest, coldest, most unknowable place on Earth. Antarctica's secrets aren't all under the ice. Some of them drift in silence, unseen above your head, shaping the sky itself. You stand now, compass forgotten, and breathe in the coldest air in the world. Around you, the magnetic field hums, subtle, vast, invisible. A ghostly force always moving, always watching. And you feel for the first time that the Earth is not a finished place. It's still becoming, still writing, still remembering, and still hiding a few things just out of reach.